Good evening to all the respected dignitaries, faculty members, and participants. Myself, Dr. Rambabu
Thank
Dara,
you.
Assistant Professor in the Department of Mechanical Engineering, Aditya University. It is my pleasure to welcome you all to Day 2, Session 1 of the Atal FDP on AI powered optimization strategies for sustainable electric and fuel cell vehicles. We are honored to have with us Mr. Satyanandan Mahadevan, a distinguished industry expert with over 3 decades of experience in automotive and energy technologies. He is currently associated with Ashok Leland as the head of Power Solution Business, where he leads the strategy, execution, and growth of engine and power solutions. He has also headed engine development activities with a strong focus on performance optimization, emission reduction, hydrogen internal combustion, and advanced control systems. Earlier in his career, he worked with Bajaj Auto as a team lead in control system development, contributing significantly to gasoline engine design and manufacturing operations. Mr. Mahadevan holds a BE honors from NIT Prayagraj and MTech from IIT Madras. He is a patent holder with 4 granted patents and has published over 15 plus technical research papers in reputed journals. His extensive expertise in clean engine technologies and sustainable mobility makes today's session highly relevant and valuable to the theme of this faculty development program. We warmly welcome you, sir, and look forward an insightful and enlightening session. Thank you.
So thank you very much, sir. Thank you very much for the kind introduction. And it's an honor and privilege to be amongst you. So happy and wonderful evening to all of you.
Thank you, sir.
So let me start with my presentation. So I thought I'll structure my presentation what I have mentioned here in the contents. So I thought I'll structure my presentation in this fashion. So just give a couple of slides, brief overview about what is Ashok Leland, then what is the CO2 standards, and typical energy analysis on a vehicle, and what are the typical strategies for fuel efficiency improvement or basically CO2 reduction, and what we do in especially in the alternate fuel domain, and few slides, interesting slides on the hydrogen internal combustion engines, and some challenges and but still, I thought I'll just explain what is this Ashok Leland all about. So Ashok Leland is the flagship of the Hinduja Group, and it's the second largest manufacturer of the commercial vehicles and trucks and bus in India. And in fact, the fourth largest bus in the world manufacturer and the 14th largest manufacturer of truck manufacturer in the world. As mentioned in this slide, if you can see, in the automotive domain, we have right from a 1.5 liter common rail engine till a six-cylinder 8-liter engine. This goes to even up to 450 horsepower in the non-emission domain. And the trucks are mentioned here, and in the buses, various buses that are mentioned here. We have a lot of engine platforms. The beauty about our company is like we use our own engines. So unlike other vehicle manufacturers, where they are using the vehicle manufacture engines from their parent companies based out of India, I mean outside of India, and also with their technological JV partners. Besides the automotive domain in Ashok Leyland, we also have a vertical for the defense businesses, and one vertical, especially what I handle now, that's called the power solutions business. So in PSB, we have four major verticals. We have one vertical for the industrial engines that goes for all the industrial applications, compressors, all the earth moving equipments, construction equipments, and so on. Agricultural engines that primarily goes on the harvesters. You have the gensets. I mean, we give the engines to our OEEs who build the gensets around the power pack, and the marine small portfolio we have. So now CO2 reduction. So we all know about why CO2 is being talked about. CO2 is a powerful greenhouse gas. It's created already a hole in ozone, and it's going to create global warming, right? And that is the reason why everybody talks in terms of this language of CO2. A lot of countries, and especially in Europe, if you see, they have taken their internal targets, like 15% by 2025 and 30% by 2030. with respect to the 2020 2019 baseline. And there are a lot of technological pathway that is also being mentioned, how to do it. It's not just about, doing what is required. It is also about how one would do it. It doesn't stop there. If somebody does not conform to that, then you can see the penalties that would be levied in terms of a non-compliance. And the penalties would sometimes make even the companies bankrupt. It's very, very tight penalty. CO2 reduction or at an R&D level could be very easy, right? We can put a lot of technologies inside and then get the CO2 reduced. But if you take it for a commercial viability, ultimately what could happen is the product cost would go up, right? And product cost going up, it means this is a burden on the end customer. So we should find out smart ways and means in terms of achieving the objective and with minimum cost addition to the end product. So that's where the challenge lies. In India typically for emissions, if you see India follow the European norms. If you take the automotive emissions or even the non-automotive emissions, we follow the European norms. The BS6 we followed from there, the CEV5 norms we followed from there. If you look at the current and future norms, for those of you who are not aware of this CAFE, so corporate average fuel efficiency norms, there is a CAFE 3 is going to come up. The CAFE 3 is going to target for about close to 92 grams CO2 per kilometer. This is not a very small number. This is a very, very challenging number to achieve. This is 91.7 grams. Whenever it is being mentioned as CO2 grams per kilometer is basically measured on the roller dynamometer. And CAFE 4, which is again looming large, this is a 70 grams per CO2. That's even a tighter number. So automakers will have a 5-year transition between 3 and 4. Nevertheless, this is going to be a phenomenal effort to achieve this, make this. In M&HCV, similar to this, when I say M&HCV, medium and heavy commercial vehicles, we have something like a HDFE. We say heavy duty fuel efficiency norms, very similar to the CAFE norms. So wherein the vehicles are typically run at say constant speed 40 kilometers per hour and 60 kilometers per hour, and the fuel consumption it is being measured and it's converted into liters per kilometer. And there are some norms levels based on the GVW of the vehicle and the category of the vehicle. The vehicle has to conform to certain targets. In the COP26, we have India as a country, we have committed in the COP26. Like as we know, the five major measures our Honorable Prime Minister has committed there. So non-fossil fuel capacity by 2030. So we say we will come down to these levels. Share of renewable energy. Again, very, very ambitious and bold targets have been taken. See, as you know, unless and until we don't take targets, we will not be able to achieve the results. These targets are extremely essential so that the overall pollution, overall CO2 comes down. At the end of the day, the fifth line item is net zero by 2070. So by 2070, this Panchamrit elements that is being listed here, they will try to get us to a baseline levels of net from a baseline level net zero levels by 2070. This is a very, very challenging target. As you know, I've just mentioned the reference from where these slides have been taken so that anybody, if he wants, he can refer to the authentic source. Similarly, based on the Panchamrit, how do we do it? One such thing, say one is the renewables, next is the EV ecosystem. When we say EV ecosystem, say available of the EV vehicles and also the charging stations and the swappable batteries and so on and so forth. Next is the ethanol for the petrol, E20, and ED and MD, that is 10% or 15% the mix of ethanol or methanol or even IBA, isobutanol, 10% levels for diesels. Besides this green fuels. Next is battery energy storage improvement. And CCS, the carbon capture and storage technology. These are all again expensive technologies that's available. I'm sorry. So at the end of the day, the details are mentioned here in this ICRA report, and by following these steps that is mentioned here, we should be able to achieve the targets set by our government. For India, if you see, the typical, let me start with the non-powertrain enhancement. Non-powertrain is basically the non-engine and non-gearbox wala stuff. Right is aerodynamic optimization. Most important thing, aerodynamic is streamlining body. Vehicles may have a roof hat or something like that to reduce basically the air drag. So a lot of CFD simulations are done upfront during the vehicle design itself, and then the best, I would say, the design for the vehicle is selected for getting the CO2 benefit. This is something that is not, very new, but we've been doing it for quite some time. When I say we, all the automotive companies are doing it, right from passenger car till the heavy vehicles. Next is the mass optimization of the vehicle. So how can we do it? Can we use some lighter materials, lightweight materials? Can we do some redesign of the structure? Any new manufacturing technologies? Next comes tire optimization. This is again a big contributor in the for fuel efficiency improvement or CO2 reduction, because both are the same end of the day. Then again, the auxiliary is optimization. So auxiliary power consumption, how we can optimize it. But the interesting point, if you see these columns, they don't talk about say 10%, 15% level of improvement. They talk about 1% and 2%. And please bear it in mind, we can't simply add this and end of the day, put a big number, say, okay, if I do all this 1, 2, 3, 4, we'll get say 15%. It doesn't happen that way. Some techniques they compound, some techniques they complement, and that's how they are. Shall I proceed? Yeah, shall I proceed or sir, any question?
Yes, sir.
Hello?
Proceed, sir.
Sir, I would like to have this session as interactive as possible. If somebody has any question, please feel free to ask me. You can interrupt me any point in time. You can unmute yourself. You need not wait till the end of the session and then ask your questions. Right?
Yes, sir. Yes, sir.
And now, yeah, if I continue the technology roadmap, friction reduction is a very important thing that every engine designer does. Right. As you know, friction is proportional to the square of the engine RPM. So if you are having an high-speed engine and if the friction levels are, somebody can go on mute, please, whomever is talking there. Hello? Yeah. So friction is proportional to the square of engine RPM, square of engine speed. So at any high-speed engines, and if there is a friction element sitting inside, so it's going to be detrimental and it's going to say stop getting the fuel efficiency benefits. It's going to deteriorate the fuel consumption. Similarly, this micro hybrid stop-start systems, then fuel injection system. So everything will have a boon and a bane. That's right. No, one is the cost part of it. Next is the technological challenges in manufacturing and assembling and maintaining the same thing. Next is the downsizing. So how can you push more and more air inside the engine with a downsize? It means if you have a naturally aspirated engine, say for example a 4-liter naturally aspirated engine, can we go to a 1.5-liter turbocharged engine? That would give a specific power that would be very similar to the 4-liter engine. Yes, people are doing it, and this is the the idea that most of the people are working. How can we squeeze the maximum power out of the engine? Smallest engine, maximum power. Other technological elements like the variable valve timing and variable valve lift, right? Cylinder deactivation. This also would come in very handy if you especially look at the multi-cylinder engines. For example, a 6-cylinder engine, and when the vehicle is idling, say maybe in a traffic signal, you may not require all the 6 cylinders to be on during the idle period. And if the vehicle is still having an air conditioning system, but depending on the power that is required, some cylinders can be cut down. Right. So this would give some benefit in fuel consumption. And if there are some drivers who are not exhibiting the best driving practice, the AMT is the solution for that. So it means that it will always try to maintain and operate the vehicle at the right sweet spot operation in the fuel consumption map. So you'll be operating at the best sweet spot so that you'll always get the best fuel efficiency. The NOx control systems. NOx, as you know, is one of the primary pollutant from the internal combustion engine. So how do you do this NOx control system? See, one thing we should know is an engine will be having the maximum fuel efficiency if it is going to operate at the best or the highest thermal efficiency, right? And if it is going to operate at the highest thermal efficiency point, temperature is going to be high, NOx is going to be maximum. So it's a paradox. So when we say the best fuel efficiency, there's the great chance that the NOx emissions will be very high. So the NOx has to be treated. How do we treat it? Either you treat it outside the engine by use an SCR, selective catalytic reduction. If you look at the today's the Bharat stage vehicles running in India since 2020, almost all the vehicles greater than 3.5 ton will be having this SCR. It's a catalyst with a dosing of controlled dosing of AdBlue or aqueous urea solution for reduction of NOx. Similarly, there's another method of treating the NOx inside the cylinder, inside the combustion chamber
Feedback link
by
from
sorry, any question? Is there a question I can take?
No, sir. No, sir. You can proceed, sir.
Yeah. So exhaust gas recirculation. So part of the exhaust gas is again taken back from the exhaust manifold. It is cooled to have a better volumetric efficiency and again fed back into the combustion chamber through the intake manifold. So thereby this will reduce the NOx formation. So there are techniques available and there are also a few more techniques. I just listed the major techniques available here and look at the quantum of the efficiencies. Look at the quantum of the fuel efficiencies that people are, expected to realize. On the vehicle energy analysis, if you take this truck that is running, there are about 5 elements mentioned here. The first element is the engine loss. Next is the aerodynamic loss. Next is the rolling resistance. Next is drivetrain and auxiliary loads. So in the past few slides, 15 minutes or so, we have discussed some points about these things. And again, the overriding factor all of here is weight reduction. The message here, what is happening is, whatever fuel energy that we expend, close to just under 20% of the fuel energy only reaches the wheels usable power. So it means the energy is getting lost in various other forms, right? So how can we first of all measure, how can we monitor, and how can we improve all these things? So there are again techniques available, technologies available. Threadbare you can analyze which particular aggregate or assembly is contributing to this fuel efficiency loss, and we can work on to improve that. Just going forward, if you look at the 8 parameters that is described here, right from the combustion engine optimization till the driving pattern. So everything is very, very important, has to be addressed here. Correct. Fuel energy, as we saw in the previous slide, some part goes to mechanical work, which is what is required. Propulsion, mechanical work again goes to propulsion and braking. And there are some resistance components that's going to eat away the hard-earned energy, right? The driving resistance, aerodynamic, the rolling resistance. There are some driveline losses. There will be some thermal losses. So it's very important how we can say, recover the thermal losses. So can we do something to say recover the exhaust energy and again use it back? If you this is an argon lab the presentation. So what is being mentioned here in this slide is fuel energy going to say indicated power again heat transfer and exhaust. How can we, threadbare analyze? How can we threadbare analyze the energy constituent, where and all this energy so-called, going as, if I can use the word waste, and how we can address it, and then how we can improve that wastage so that useful energy is realized, and therefore, at the end of the day, the overall CO2 gets improved. So Cummins had built a vehicle many years back targeting 55 percentage overall efficiency. So 55% is a very, very challenging number, and they've achieved on one vehicle. There are some papers and literature is also available. Somebody was interested, you can go through and find out also. How did they manage? What are the techniques that they adopted to get that very high fuel efficiency? Some techniques that we mentioned here, the ORC, and then insulation, friction reduction, auxiliary loss reduction, and then the variable geometry turbocharger, redesigning the combustion chamber, very high pressure fuel injection, and take the engine to extremely higher cylinder pressures. So there is the European standard, and based on that, what and all we can do, right? This is an AVL source of slide here. What they said is, which could be pretty realistic, is we can achieve about 15% of fuel efficiency to a baseline level, from a baseline level where we are. But for that, a lot of work has to be done here. Like it is mentioned here, plenty of work needs to be done here. It's not a one element or two element that we do, and it's going to give that the ultimate result of fuel efficiency improvement. So there's a whole lot of activities needs to be done, and the most important is it has to be realized on a mass production level. It means we need to do a lot of consistency trials. The parts that we source, the technologies that we source, they have to be extremely consistent. Otherwise, one customer may get, the other customer may not get. But at the end of the day, when these things become a rule of the law, it has to be met. There is no other option, right? So in an engine efficiency, how can we improve the efficiency of an engine? Internal combustion engine. First, you can improve the combustion and air handling. When we say combustion, a lot of software available in the market to say model the combustion and get the best combustion chamber design. When we say air handling also talks about turbocharger. So have we selected the right turbocharger, right turbine, right compressor combination for the particular operation of the vehicle, of the engine, right? Is there any possibility that we can recover the exhaust heat like an organic Rankine cycle? Can we recover the exhaust heat and then use the heat for some other purpose? At the same time, you can thrift some. It means there is over that. So that amount of fuel consumption can be again thrifted. So how can we reduce the heat loss? Heat loss to various sources like heat loss to coolant, heat loss to exhaust, and so on and so forth. How can we improve on the friction and the parasitic load? This is again an important thing. And end of the day, how can we optimize the engine out NOx emissions? As I mentioned, NOx emissions is a direct function of your thermal efficiency. So can we do something, deliberately increase the engine out NOx, get the best thermal efficiency, and have an after treatment system that is wonderfully designed so that the NOx emissions are addressed, treated, so that the compliance, everything is met. There are a lot of fuel efficiency strategies that are being listed over here, and most of the industries, the automobile companies, they follow these bulleted points. They may not be following all the bulleted points, but most of the bullet points are being followed. So I don't want to read all these things because you can read it, but I want to say specifically touch upon a couple of things. For example, if you go for the cylinder pressure, if you can go for a very high cylinder pressure, what is required, especially in the combustion chamber, is people go for steel pistons. So from an aluminum piston, then we go for a steel piston. So steel piston means again the reciprocating mass is going to go up. So then can we do an optimized piston design? Only the limited mass that is required. So that can we do some thrifting on the mass of the piston? Next comes is turbocharging. Can we go for a two-stage turbocharger? A low side and the high side. The two-stage turbocharger. Would it be efficient? So maybe my vehicle, if it is operating in some particular condition, the first stage will come into the picture, the otherwise second stage will come into the picture, and end of the day, it will be super efficient. Next, can we do downsizing? For example, if a vehicle is running with a six-cylinder engine with say X horsepower, so can we use a four-cylinder engine and deliver the same X or even better than X horsepower? Is it possible to do? Yes, people are doing it. People are doing it, downsizing. So therefore, the engine design, robustness, the serviceability, everything has to be taken care of right from the design stage itself. For heat loss reduction, can we insulate the combustion chamber? For example, can we coat with some kind of a heat barrier coating on the piston top or cylinder head bottom so that the heat is retained inside the combustion chamber? So instead of dissipating the heat outside, can we retain heat inside? And another thing is, can we use some say wonderful oil? Okay, so very low viscosity, high performing oil so that the friction contribution from the viscous oil is negated. So there are many ways it's being done, right? But end of the day, we have to do these things, otherwise the end goal will not be met. Again, FE concepts for enhanced BT's brake thermal efficiency. So what and all we can do? For example, there are some companies who do this. This is the super truck program is a 55% brake thermal efficiency and various techniques. Typically, diesel engines have compression ratios of the order of say 17, but here if you say people are going for 20:1, so you increase the compression ratio. Similarly, cylinder pressure, very high common rail pressure, injection pressure. And restriction in the exhaust slide is very less. It means you are reducing the back pressure because back pressure is going to affect fuel efficiency. Can you do downsizing? So many ways are required here. And this is an open book. You can search in the internet. And if you look at the Cummins Super Truck program, you will get plenty of information in the internet also so that we can relish later these ideas. And if you typically look at a haulage application market, right, and a diesel engine is operating, typically the power that is coming at the wheels, it's very less, right? A lot of losses going. So every single component in the engine, in the gearbox, that's the transmission, in the propeller shaft, in the differential, and in the tires. So everything has to be addressed, not just in the drivetrain, also the aerodynamic losses and the mass, overall mass also has to come down. So this would require a complete collective effort, right, at an organizational level to realize these benefits. And similarly, once we do that, so the improvements can be realized, yes, but one may not get an improvement of say 15%, 20% levels. Even a 4%, 5% improvement is a big number in these activities. So in Ashok Leland, we have a fuel efficiency idea generation tool, idea generation platform. So where the ideas are collated, and then it's all classified based on the complexity and benefits, and based on that, it goes into the various stages of implementation. An example that I've shown here is in terms of the combustion chamber technologies, how the combustion chamber is modeled. What is the purpose of doing it? We are doing it to enhance the fuel air mixing, improved fuel air mixing in the case of an EGR engine. So how can we also mix the EGR very nicely inside the combustion chamber so that the in-cylinder emissions are minimum and the in-cylinder efficiency is the maximum. So that is the challenge that people take. This is the reference from I'm sorry, it's a China paper, and people do a lot of research and simulation in the combustion chamber. So we also do research and simulation in the combustion chamber, arrive at the best geometry. Okay, the piston top should be something like this. The location of the nozzle should be something like this. So likewise. Similarly, there is another technology called jet controlled combustion ignition technology, that is called JCCI. So what they do is it is a small separate injection ignition chamber engine. See, look at it. You have a small gas, it's an LPG gas going here. There's a spark here. So it's kind of a pre-combustion. The main combustion happens here. So this will definitely give the advantage of homogeneous and heterogeneous combustion, but end of the day, it's going to add cost, because diesel engine will again have to carry a spark plug, a separate an LPG fuel, and a line. Look at the controls. So what controls and all we can have today, or what are we having today? See, in the BS3 emissions, if you all know the BS3 emissions, people used to do with a mechanical fuel injection system, right? So it is completely mechanical. So when BS3 became BS4, a little bit of electronics came. Hmm? Electronics means what? The common rail system had come, so people had to understand the wiring, the electronic sensors, actuators, connectors, and so on and so forth. In the BS6 regime, it is not just the electrical electronics instrumentation control part, it is also the chemical part of it. So when we did this BS6 in 2020, I mean, All India BS6 was launched in 2020, the engine and the after treatment system was equally complicated. So every mechanical engineer who in turn turned into an electronics engineer was again, reading the chemistry books and literature to understand what is this chemical part happening in the catalyst, right? What is this light off temperature? What is this phenomenon of, say, thermolysis, hydrolysis in urea? Then what is this regeneration? What is this various kinds of deposits that is sitting in the SCR? How can we, break them and all those things? And what are the models that we can develop and adopt in the app treatment system so that you need not depend on the sensor all the time? You should have a fail-proof system. If the sensor fails, so what is the alternate? Likewise. But if you look at the models here, there's so many AI-based tools and technologies available. Knock detection is a very simple algorithm that most of you may be aware of. For example, if you take an SI engine, a knock detection, any knock is detected by either a G sensor installed, or it looks at the instantaneous crank acceleration. And based on that, we can figure out which cylinder is knocking, and we can take a corrective action. We can retard the timing, wait for a couple of moments, and then you can advance. So I don't want to have a lecture course here, but at the end of the day, there are you all know these things. But the point here is people are deploying all these ideas. Therefore, with every single idea is important, because the ultimate goal is very, very challenging. It's very tough. Next is the combustion rate shaping. So can we shape the combustion pulse in the way that we want? Please imagine that if it is solenoid injector, if we just energize the solenoid, it's going to lift, right? It's going to be a simple box kind of a plot. But then here, can we have the shape that we want? Right? So this is a thought process. People are doing it. Many controllers are having these strategies, and this will again to the emission part of it. So you'll have a perfect combustion and emission. So if you look at the where we have started, 2020, when I said BS6 in Ashok Leland, so we had the baseline IC engine, we have the electrification as also on CNG. So the 2021 to 2030, we call this a decade of transition here. So all sorts of fuels will be available, all sorts of environment will be available, ecosystem will be available, and that's what the market demands. So greater than 2020, nobody knows, right? So what is the fuel? I mean, but there are talks that diesel may not continue, and there are also talks that Europe is going to reverse the 2035 norms of banning the ICEs. And nobody knows what's going to happen now. So, but the message here is we have invested in development of all the product portfolio available, and whenever there is a demand from the market, so we can suitably adopt the product and then deliver to the customer. End of the day, we have to meet all these things. As you know, today 86% of our crude is imported. So can we do something to crude import substitution? That is the reason we are having, say, working with the biofuels, like say ethanol, alcohol based, and then biodiesel and so on and so forth. So that will contribute to a reduction in the our import bill. And again, if you look at the alternate fuel initiatives, what we have taken, right from 1994 till where we are. So almost we have seen we've been a market leader in using of all these fuels, and we have demonstrated a lot of vehicles for for a demo purpose, for R&D purpose, and also for commercial purpose. Last 3 years or so, we are running the hydrogen engines in our facility. Next couple of years, we should be ready for launch. And if you look at the CNG, Ashok Leyland, we have a very wide range of CNG fuel vehicles. Because in Delhi NCR area, there are no diesel buses, only CNG buses. So there are certain corporations, certain areas where the mandate is to go for CNG buses, and and later on electric buses also. So we are prepared for that. Then how do you convert? So the first thing that the customers may ask is, can you do a retrofitment? Can you convert an existing diesel engine to CNG engine? So as you all know, diesel engine is a compression ignition, and that CNG is a gas, a spark ignition engine. So there will be changes in terms of modification, the compression ratio, the piston geometry, spark plus interaction, cylinder head, and you need to add an ignition system, and you have to add a gas injection, and diesel operates in a very, very lean combustion environment, right? And CNG SI engines typically operate in lambda equal to 1 kind of an environment, so that the catalytic converter efficiency is the best, so on and so forth. So
Sir, I have a
just one quick.
question on the previous slide. Are you saying the diesel engine conversion is possible to CNG?
Yes, we have done the retrofitment.
Acha, okay.
This is a retrofitment. See, naturally, no, the combustion chamber has been modified, as you know, right? Compression ratio can be only in these levels. Next is you need to modify the cylinder head, because you have to have the spark plug in place. Then the intake manifold and all those things, the gas system, gas reel has to be installed. Correct.
Okay.
And the calibration, everything has to be done so that the lambda equal to 1 is met. The catalyst will change. Catalytic converter is going to change. And naturally, the vehicle needs to have the CNG tanks and plumbing and all those stuff, all the safety related stuff. Initially, people would want to do that instead of straight away going into it. But once there is a confidence level, they'll directly go into CNG vehicles.
Because I heard, petrol conversion to CNG, but yeah, I never heard diesel conversion to
Yeah,
CNG.
petrol and CNG is almost the same, right? It's a SI to SI. Compression ratio could be maybe 0.51 here and there.
Okay.
Aftertreatment system could be more or less the same. Gas handling would be different. Gasoline handling has to be replaced with gas handling. So being gas, we need not bother about mixing. Gas naturally mixes well with gas air. So the mixing part, we not much worry about.
Have you done any kind of a mass conversions on this concept?
No, we have done that. In fact, when we started running our hydrogen program nearly some 3 years ago, one of our customer wanted to run some 20 plus vehicles. So
Okay.
they have given the baseline diesel engines.
Okay.
Hydrogen is also very similar to the CNG, very similar. I won't say the same, it's similar. Because then we did the conversion and the vehicles are running still now.
Okay. Okay. Wonderful. Thank you.
It is going to be expensive. It is definitely going to be expensive, right? It's going to be expensive, but it is not impossible. We have done that.
Okay.
And again, from a CNG, right from first generation BS1 to today, we are in a BS6. What are we doing in BS6? It's stoichiometric plus an EGR. We have, of course, very electronic closed loop control. We have an OBD2 and IUPR monitoring, and emission durability is also mandated. And BS7, nobody knows Euro 7 when it's going to come, probably 29, 30 or 27 or so. But again, we are ready for that. And someone earlier asked, so typically what would be the changes? So other than the engine level, what you mentioned, if you look at the engine, CNG engine, then the electrical part of it, wiring, fuel system, cooling system will change, right? The controller will change, the program is going to change. Of course, the modification of the vehicle chassis to say take this all these tanks and all will change. Then the app treatment system is going to change. Sensors related to the CNG will be changing. So it is not impossible. We have done in the past similar thing we done for hydrogen also. And a quick glance into the legislation and the safety checks. So once we do this conversion, naturally all these items needs to be certified. So there are competent agencies to which we have to, submit the vehicle, and they will be performing all these tests at whatever standards prescribed. So and then we have to get it on type approved. That's the type approval is for any fresh product that we do. And we also mentioned here like which are the agencies that typically do it. A cylinder is being done by PESO, and then so on and so forth. This is probably of little interest to you. And CNG infrastructure, this is from our facility in Ashok Leyland. So where the CNG cascade arrives, and then the CNG cascade, how these cylinders are connected, and the cascades are down, and the gas release, and end of the day, finally it goes to the engine at whatever prescribed pressure. And again, LNG. See, the difference between CNG and LNG is especially in the tank part of it. It means the tank, we need to have a heat exchanger and so cryogenic tank, heat exchanger and a regulator. Other than that, it's all a CNG engine only. So LNG naturally will have a better range on the vehicle level. A big tank can bigger tank can take more gas, and therefore it can cover more kilometers. That's the whole purpose of going for an LNG. Otherwise, it's the principle is very similar to the CNG portfolio itself. And coming back to the LNG fuel layout, this is again is a commonly available information. So what is a tank? So again, the software is very critical. We need to monitor all these things, all this every single sensor actuator or the controller will be modified by the ECU, and any something any excursion would be taken corrective action. Safety is of paramount importance here. Again, LNG, we run some LNG intercity buses. The size of the tank is very big. As I said, we maintain is about 162 degrees minus. That's the tank temperatures. Therefore, we need a heat exchange. It's in liquid. Right? Need a vaporizer, regulator, and then goes. So for those of you who are not aware, I think most of you may be aware of it. This methane is even a powerful greenhouse gas than CO2. I think methane is about 80, 90 times as potent as a CO2. It stays in the atmosphere for quite long time. So the greenhouse effect will be longer in the case of methane. So any unwanted methane exhaust or the gas is not burned properly. So it's all regulated. Be very careful in doing that. Again, what are the benefits of CNG over LNG? As you said, the range is better. The space, as it is in liquid, you compress more and then you carry more, I would say, more fuel. So that's the biggest advantage of CNG. Even now, there are a lot of LNG tanks running. So as I mentioned sometime in the past, like a hydrogen engine, right? So a typical conversion. So how do we convert a hydrogen vehicle from a diesel vehicle? Again, the critical elements will change right from the engine. You need to have a tank, all the wiring, so on and so forth. So as I said, we did over more than 20 vehicles, converted this in this route, and then these vehicles are still running in our country. So our engines, when the engines are being designed, it's all we say is a fuel agnostic engine. So naturally, the cylinder head would undergo a change because diesel cylinder head cannot be considered for a SI version. So naturally, when it goes for a SI fuel, then the SI based architecture will come into the place. But nevertheless, all other components will remain the same. So that's the beauty of this fuel agnostic engine with bare minimum changes. So the design, right from design stage, it's conceptualized so that the usability of the engine for various applications is well forethought. So again, if you look at the hydrogen engine unique components, so if you look at the bottom row, that's your hydrogen engine, and naturally the injection system is going to be different. Ignition system is going to be different. As you know, hydrogen has got the highest flammability limits, right? 4 to 76% is the flammability limit. I think diesel is around 9 to 11% or that range. So it requires extremely low energy. So it's very, very important that we have a plug and a coil so that, uh, carries minimum of energy required to burn the fuel. And hydrogen flame speed is very fast. I think it's 7 or 8 times faster than the conventional flame speed. And because of that, it's very important that we do the optimization of the fuel injection. The backfiring is avoided. And again, the electronic throttle body is required to control the airflow, and if required you need to go for a variable geometry, and hydrogen operates very lean. The stoichiometric ratio for hydrogen is about 33 or 34, uh, and at full load conditions we tend to operate at lambdas as lean as 2.1s and 2.2s. It's an unbelievably lean fuel, and the combustion chamber will change, and therefore there are some mandates that the crankcase has to be monitored because the crankcase pressure at any point in time should not exceed the not the pressure the hydrogen concentration inside the crankcase at any point in time should not exceed 4 ppm, because beyond 4 ppm then hydrogen can burn, can just if there is a source of heat or energy. So therefore, there are techniques and technologies available how to positively vent the crankcase at the same time maintain the pressure, the ppm of hydrogen lower than 4 ppm. So this is one of the our hydrogen engine we displayed more than 2 years ago in the Auto Expo. The engines are doing a lot of durability and tests happening on the engine dynamometer level and also on the vehicle level. Some changes we mentioned. So, so people say that this is going to be the fuel of the future, but I foresee there are three challenges. There will be some challenge in terms of developing the engine. It's not as easy as we do a CNG or a diesel, but of course this can be learned and this can be applied and we can overcome this. But the three main challenges I foresee is the availability of fuel, the transportation of fuel, and the storage and handling of the fuel. So these three things are primarily see the challenges for hydrogen. I think today hydrogen it's about $5 or $5.50 per kg. I think probably if the price drops down to say it's about under $2 per kg, then it would probably be matching with the diesel levels of economics. And again, this is a live photograph from our hydrogen storage yard. So how hydrogen is stored. So you need to get proper approvals from the competent authorities. And then once it is stored, and then we ran this engines with Reliance for about 23 vehicles. And it was in fact flagged up by an honorable Prime Minister. This is some 2 years ago, more than 2 years ago.
So the cost of hydrogen fuel, you said somewhere around $5, crazy. But how about
Yes,
fuel efficiency on the vehicle?
we can match diesel levels of fuel efficiency.
Okay.
This again is in terms of kg, right? See,
Mm-hmm.
hydrogen fuel is I would say is being the lightest fuel. For instance, a big tank cylinder, huh? I would say it's a big 300 bar tank, that typically carries about 250 bars of hydrogen. That is roughly about 2 meters length and about half a meter in diameter. that would take about 8 kilos of fuel. Right. So that's why people go for 700 bar tanks. Again, 700 bars. I think in India, we don't have approvals for 700 bar tanks, but in Europe, it's there. So 300 bar tank, and then it's going to be a Type 4 cylinder, composite cylinder. And I don't think we have a Type 4 manufacturing in India. Probably my information is old. Maybe so there are somebody who are doing it. So the Type 4 cylinders, that's why it's all it's a cat and mouse game. So people will say once the volume starts to improve, then the cost will come down. And the other thought process, the cost has to come down for the volumes to go up. That's how it is.
When we talk about conversion from diesel to hydrogen engine, hydrogen
Mhm.
fuel, the laminar burning velocity of hydrogen is around 3 meter per second, whereas diesel is around 85 centimeter per second, 84 to 85 centimeter per second. So how to overcome that specific situation?
Yeah, basically what we look at the flame speed, right? This is a very important point that you touched about. How to reduce the flame speed. See, one technique that people use is induct EGR, right? EGR is typically used to bring down NOx emissions in diesel. But in hydrogen, EGR helps in slowing down the combustion. So the combustion rate, if you look at the combustion rate without EGR tends to slow down the combustion. So therefore, you can pump in more fuel and get some more energy out of it. Other techniques is optimize the ignition energy, optimize the spark plug, and optimize the compression ratio, and optimize the most important thing is air handling. It's very important to have the right calibration in place. Hydrogen burns very lean, as you know, and so the turbocharger has to be extremely suitable to deliver that high capacity of air for the engine to run. But end of the day, we are matching or diesel levels of performance. A lot of
So, but if we
advantages.
are inducing
Pardon?
but if we are inducing more fuel, then the knocking will happen, sir, because calorific value will come around 1.5 megajoule for hydrogen. 1.2 to
Knocking
1.5.
can be controlled. Knocking can be controlled. That's why we optimize. EGR also will slow down combustion, slow down knock, right? And compression ratio you can low down by 0.5 or 1 to bring down knock. In hydrogen, more than knock, it's the backfire. Because of the very, very high flame velocity, the fuel tends to go from one cylinder to the other. Any hot spot, for instance, if there is a very thin, minuscule oil sitting somewhere in the valve or somewhere, right? So that becomes a hot spot. And this gets transported between cylinders to cylinder during the combustion process. And therefore, you get backfire. And if you do a research on hydrogen, especially on backfire, you will find n number of papers written about backfire. So that is what our experience is. So the biggest challenge with hydrogen is backfire. How to handle that backfire? Because it's detrimental. The temperature goes up very high. Just within seconds, the temperature shoots up, and the whatever sensors that you have just literally burns with that temperature. In knocking ke liye, we have other strategies available for knocking also. The controller can figure out the knock, as I said, based on the instantaneous crank acceleration. We can do a timing retard, and then again we can do it. So optimization of combustion chamber is also very important, so that the knocking part is also addressed. Have I answered the question?
Yes, sir. Thank you.
Yeah. So as I mentioned here, so what are the learnings that we learned in hydrogen? Like say the ignition coil, which should not be any ghost or secondary sparking. Extremely low energy, turbocharged variable geometry turbocharger to provide very high airflows, and the piston subassembly, and the second ring gap to be twice of the first ring gap. So very important learning that we learned. And there are several types of spark plugs available: cold rated plug, ring type or a J type, and then oil, crankcase ventilation. And the important thing is cooling air on spark plug, and no sharp edges in combustion chamber, because that would again become like a hotspot during combustion. Hydrogen embrittlement is again a challenge that can be overcome. So metallurgically, we can overcome those challenges. Hydrogen embrittlement, and if you look at the combustion stuff, so EGR will help to mitigate the backfire and the knocking. Again, plug gap is important. Timing, fuel injection duration, Placement of injector is also very important, and extremely fast combustion, very low lambda, and compression ratio. So this is what we are, at a very mature level of hydrogen. As I mentioned, we can get diesel-like performance and torque is achieved. Again, a lot of learnings from the hydrogen internal combustion engine development here. So right from the hardware selection, see a hardware design selection, and again the P&D, the performance and emission. The NOx levels will be very, very low because the fuel does not have any, it's I would say at very lean lambda, say 2.2 levels, you'll get single digit ppm of NOx. That's very pleasing to see that level of extremely low levels of NOx. So there are some combustion graphs that I have ported here. So the combustion has a low PFP because again the compression ratio is also on the lower side, and in the exhaust you don't see smoke. You typically get water vapor and the white color thing. And as you know, as you go beyond the lambda 2-ish levels, then you get typically single digit ppm of NOx. So this is typically how the tanks are installed right behind the cabin here. So in this example, 3 tanks. Sometimes a fourth tank can come here and the fifth tank can come here. And then as I mentioned here, a tank of say roughly 2 meters, 2.3 meters long and about 660 millimeters diameters, it can hold about 8 kilos with a range of some 300 kilometers. There are some initial figures, but end of the day, it will get only improved. But today, if the ecosystem is available, then we can go for this fuel. So again, some thoughts about fuel cells. So I don't want to see why I just brought this fuel cell here is as you know, the challenge with the fuel cell is the purity of hydrogen. People say fuel cell requires 99.9999 levels of purity for a fuel cell. And the air has to be extremely clean. Filtration is extremely clean. But in the case of diesel, I mean, an internal combustion engine operating in hydrogen, even a 98% purity is also okay. So we need not go for that very high, extremely levels of purity with the uh, fuel cells.
You are referring to Six Sigma.
Yeah, sort of. So if you look at the fuel cell FC vehicles, again, we'll have the typical architecture here. The fuel cell will be sitting somewhere over here. We have the tank and some specification of, in fact, we are operating a few fuel cell buses in this Ladakh Leh area, the government project we are running there. So our typical bus architecture looks like in the case of fuel cell. And again, another couple of slides on the EV vehicles. So the thing is, today when you say EV, so EV battery is only a storage device. It does not generate energy, right? Like a fuel, it doesn't generate energy, it just stores energy. And as long as the entire well to wheel is taken care of, then the holistic concept of green may not come here. So now our country is also going up very hard and strong in terms of battery manufacturing, how much we can localize in India so that the dependency on other countries are coming down. I think I'm in my last slide. The medium and heavy commercial segment. So CO2, what is CO2 standard? We touched upon what is CO2 standard and why and how it is important to understand the various sources of losses in a vehicle and how we can address them. So how we can improve the brake thermal efficiency, how typically the idea generation program works in terms of fuel efficiency, and then what are the advanced combustion improvement techniques that are available and which can come in handy to improve engine efficiency. We also discussed about the fuel agnostic vehicles as a part of our net zero carbon initiative. and the modular, how the vehicles are considered with the modularity in place. So wherein a vehicle can take an EV package or a fuel cell solution or an IC engine solution or a CNG solution. So the modularity, how it is all conceptualized at the design stage itself. And we discussed a lot about hydrogen, and again backfire, again thermal efficiency of hydrogen. So I think I'm done with my slides. So I'm open for any questions now.
Participant, any question is there? You can please ask.
Sir, recently in the newspaper and all, we had some discussions regarding ethanol mixing and all.
Mhm.
So, what whether your team has worked on any ethanol mixing or any other alternate methods for that, sir?
Yeah. See, as I mentioned, ethanol, it requires some kind of a blender. It doesn't mix naturally. We need to have a
Yes.
blender to mix the ethanol and diesel. So therefore, that's why the ministry is now recommending or suggesting to use IBA, isobutanol, IBA 10. And IBA 10 also we have tested the engines for performance emissions. The emissions are more or less there, but the performance it's 1 or 2% of the lower side. But I think it can be improved. But yes, we are ready in that line also.
But how does that affect the cost efficiency in that, sir?
No, but end of the day, the our crude is about 86% of our crude is imported, as I mentioned.
Yes.
So the lower and lower the higher and higher we consume this alternate fuels,
Yeah.
the better we'll have in our forex kitty.
Yes. Yes. Thank you, sir.
Participant, any question is there?
So the way you tried to retrofit diesel with CNG, have you tried to retrofit with the earlier engines with EVs as well?
No, EVs will be different actually because the storage space of batteries and will be different, right? But now in this new version with our modular vehicle platform, right? In a modular vehicle platform, the vehicle is literally can take any kind of powertrain.
Sir, in the starting, you were told that organic Rankine cycle to increase the efficiency.
Mhm.
Generally, in IC engines, we will go with the auto or diesel or dual cycles. If we are using a Rankine cycle, what are the components we need to install extra?
No, we
How
have
much
not tried that.
efficiency?
I'm telling you, we have not tried that, but there is literature available. The Cummins Super Truck program, they had tried this ORC. It is an expensive proposition, and the end product cost is going to go up. The thing is basically you are recovering some heat, right? We are recovering some heat from exhaust, and then we try to identify sources where and all we can use the heat. In colder areas, it will be better. So for heating and all those things, but in tropical countries like us, we have to see the possibilities of using that, and it's going to be expensive.
And turbocharging is also same thing, right? We are extracting heat from exhaust gas.
No, but turbocharger is to boost the specific power. ORC is a different ball game altogether, right? You need to have a specific set of hardware to be installed. But nowadays, almost all the vehicles are having turbochargers. If you take a commercial vehicle, almost all vehicles are having, otherwise you'll not be able to downsize the engine. And there are commercial vehicles who are going to the next level. That is, they have an electronic wastegate control. They have another level called twin stage turbocharging. They have another level called variable geometry turbocharging. Various technologies available in turbocharging.
Okay, sir. Thank you.
Any other participant having any questions?
I was doing one project on hydrogen combustion few months back, where on that I stuck after 30% hydrogen blending in SI engine because knocking was playing so much. So like instead of doing direct hydrogen combustion, can we go for ammonia decomposition?
A lot of vehicles running in NCR area is about 18% hydrogen CNG, we call hethane then. I think we were limited to 18% because the steel and the piping, the plumbing that we were using then were not able to withstand more than 18%. That's what I'm told. So beyond that, the embrittlement or the pipe failure could happen. That's the reason why we attained. But ammonia and all, we have not tried. Whatever we are doing, look at the final end product. So can we commercialize this? So whatever R&D that we are doing, can we convert this R&D into a usable product for the end customer? At the same time, he gets benefit in terms of fuel efficiency, a lower cost, and overall, it's going to be environmental friendly. The pollution has to be on the lower. For example, if you speak about ammonia, then you should have a source for ammonia carrier in the vehicle, on the vehicle, correct? Hmm? So then we need to
Yes,
have
sir.
some kind of an ammonia generation. How do you store ammonia? How do you, move the ammonia from that storage space to the engine area and so on and so forth. I would say I think ammonia is typically used in the very large marine two-stroke engines. But I don't think people use in the automotive front. It won't be economical.
Okay, sir.
Any other
Even for
participant?
passenger,
Yes, sir. Yes, sir. You can proceed, sir. You can proceed.
even for the light commercial vehicles, small ones, if there is an option given to customer that if the customer wants an SCR vehicle or a non-SCR vehicle, of course, meeting same BS6, the customer preference is towards a non-SCR vehicle because he is sometimes bothered to carry the additional fluid on board. That's the urea, even though it is available in all the filling stations, but still, that's the mindset we have.
Sir, as per the CO2 reduction concern, um, the, we should focus to reduce the different losses that you have explained and to reduce the CO2 emission in IC engine based vehicle, or we have to change whole technology by converting EV or some other newer technology for the reduction of CO2 emission.
See, ultimately, if you say EV means there is no tailpipe, correct? So there is no question of any emission from the EV. And next thing is for a sustainable environment, and do we have all these ecosystems for EV ready in India today? Maybe it's a question mark. For example, if we want to run a truck from, say, for example, Bombay to Delhi, right? So is the EV truck, huh? So do we have the EV infrastructure ready? I don't know. Similarly, if somebody wants to run a truck from, say, Delhi to Calcutta, so is the EV infrastructure in terms of charging, everything is ready? We don't know. So it'll take some time for the ecosystem to get matured. And next comes, do we have facility in India, to have the raw material here for making the batteries? Maybe the answer is not yes. So we are dependent on somebody to say supply us batteries. Then again, what is the life of the batteries? Say 5 years, 6 years, whatever they're going to say. And then what are you going to do with the afterlife of the batteries? Then I'm going to say, reprocess or repurpose the batteries and make it. So there are a lot of companies, in fact, as you know, they're doing this repurposing of batteries, especially on the two-wheelers and even the cell phone batteries. And there are people doing it. But with the context of the automobiles, that is the reason why in India there is no clear-cut rule saying that this vehicle has to be with this fuel or this vehicle has to be with that fuel. It's not like that, as I mentioned earlier. So every fuel is required, and all customers, some areas they demand EV, some state transport units they demand EV, right? Some state
So it
transport
means
units
that
they demand a
dependency.
CNG vehicles, and some people are some.
So it means the dependency of ICNG will be there in India because of lack of infrastructure of
Of,
EV or all that.
of course, of course. Even if you go by your car, take a car on a long distance route, and if a truck is going to give you, for example, a range of 300 kilometers, I'm just taking some arbitrary number, then it means if you're traveling on a journey, say 1,000 kilometers, so at least you need to recharge, right, 3 times. So do we have the facility there? I'm
No,
not saying
okay.
some areas we have, some areas it's available. And it will come one day or the other. But till the time, IC engines, the so-called range anxiety, availability, so it's going to live for a long time.
Moreover, carbon emission for EV is from EV is more, not from the tailpipe, but at the time of lithium mining and then like decomposition of the battery, so emissions are more, and the electricity which we are producing, that is most of the electricity which we are getting produced in India is from coal only.
Correct. That's why we should look at the well-to-wheel perspective. So if there are no more questions, then thank you, Professor, for the opportunity given to me. And it's a wonderful audience, very nice interactive session. And if there are any more questions also, you may reach out to me through Professor. I'll be more than happy to answer whatever I know. If I don't know, I'll find some answers and try to answer you.
Sir, I have one question, sir. Dr. Yalu
Please, sir.
Sir,
Yeah.
actually, I heard the news recently in USA they launched hydrogen vehicles.
Mhm.
Uh, when it will come for India, sir? Who is working on it?
Sir, as I said, hydrogen now, every automobile manufacturer is working on hydrogen. Every single automobile manufacturer is having hydrogen product. I can say that. But they're waiting for the ecosystem. The availability, storage, and handling and transportation of this fuel. And ultimately, the fuel has to be, see, hydrogen fuel is not naturally available, right? It is only naturally available in sun. So hydrogen has to be produced somewhere. So once the fuel price becomes cheaper, say for example, less than $2 or less than $1.5 per kg, then it will be a really, really tough fight with diesel.
Okay, sir. Okay, sir. Sir, another question. For example, recently the ethanol government given permission to add, sir, in diesel or petrol.
Mhm.
Some of the complaint raised from customers, engine something problem came.
Mhm.
It is true, sir. But I heard the newspaper.
So
What about
naturally,
that?
no, if you look at the calorific value of diesel and ethanol, they are not the same, right? Calorific value of ethanol is a little bit on the lower side. So therefore, you need to inject more ethanol. But end of the day, people are trying to get and match the diesel level performance. And there will be some side effects with ethanol in terms of the corrosion part of it, and that is also addressable. With the right design in place, the hardware in place, it's all right. And today, legally, we are in petrol. Legally, we can mix up to 20% of ethanol.
So, as the government have given a permission to use ethanol up to 20%, so is
Ji.
there any modification required in a engine or in conventional any of the engine we can use this E20 fuel without modification?
So latest engines, when I say latest engines, they will be compatible because the fuel, the plastic, and the rubber and all, they'll be compatible to ethanol. If you look at very old engines, probably maybe 10 years old or that kind of engines, then we may have to look at the right from the fuel tank till where this ethanol gets into the chamber. And also the hygroscopic nature of fuel also needs to be addressed from the oil perspective also. Yes, there are a lot of prescriptions readily available for older engines.
Sir, I think no, sir. Thank you so much for your valuable section, sir.
Thank you very
Really,
much,
it
sir.
is very
Thanks.
amazing, sir. Thank you so much for
Thanks for
accepting
the
as a
time. Thanks
resource
for the
person.
opportunity. Thank you. Thank you very much.
Yes, sir. Yes, sir. Thank you so much.
Really,
Sir. Thank you
really,
so much.
very, very enjoyable and very, very truthful session.
Thank you very much, sir. Thank you. My privilege. Thank you.
Thank you, sir. Thank you, sir. Thank you so much.
Good day, sir. Thank you. Bye-bye.
Good evening, all. Myself, Dr. G.V. Krishna Pradeep, currently working as Assistant Professor in the Department of Mechanical Engineering, Aditya University, Surampalam. It's my immense pleasure to introduce Mr. Tilagaras A, working in River Mobility Private Limited as a team leader in Bangalore. He is having over 10 years experience in the automotive and electric mobility industry, specializing in multi-regional service management, dealer, network development, customer experience and enhancement, and service process excellence. Strong track record of managing large services territories across Tamil Nadu, Karnataka, Kerala, Andhra Pradesh, Telangana, and Goa, delivering operational improvements, driving profitability, and elevating workshop performance standards. Expert in delivering and implementing services of SOPs, LMS platforms, CRM enhancements, TAT reduction initiatives, warranty governance systems, and structured audit frameworks. Demonstrated success in improving CSA and PS, strengthening dealer capability, and building efficient service teams through continuous coaching, technical training, and performance monitoring. well versed in compliant management, RCA, quality improvement methodologies, and field technical support. Professional experience includes key roles at River Mobility, DriveX, Piaggio Vehicles Private Limited, TVS Motor Company, Hyundai, and Capital Honda, contributing to national service transformation projects, large scale virtual training initiatives, around 3,000 plus PGMS, BS6 training module development, and new workshop setups with complete manpower, process, and compliance readiness. Notable achievements including standardizing 50 plus service bulletins, maintaining Google ratings above 4.5 across workshops, and expanding dealer networks within the compressed timelines. Significantly, early career exposure as a technical trainer with top engineers, conducting seminars and hands on automotive technology workshops for engineering students across reputed institutions such as Anna University, NIT Trichy, BITS Pilani, and over 30 plus colleges nationwide. Delivered sessions on IC engine mechanisms, automotive systems, and emerging vehicle technologies, enhancing student understanding and practical exposure to the automotive domain. Core strengths include after sales, strategy execution, workshop profitability management, dealer performance improvement, customer satisfaction programs, quality reporting, and cross-functional collaboration with OEMs and R&D. Quality, sales, and vendor partners. Recognized for operational leadership, analytical ability, and a strong customer-centric approach. Holds a bachelor degree in automobile engineering with professional interest in automotive technology trends, customer experience enhancement, and workforce capability development. On behalf of management and Department of Mechanical Engineering, I cordially invite you, sir, for the faculty development, AACT sponsored faculty development program on AI powered optimization strategies for sustainable electric and fuel cell vehicles. Thank you, sir. Now session is hand over to you, sir.
Thank you
Thank you.
so much, Pradeep.
Thank
Thank
you
you.
for
Thank
giving
you.
this opportunity, sir. Elimale, sir.
Yes.
Thank you, Pradeep sir. Tilak sir, you can start the session, sir.
Yeah, sure. So,
Okay.
team, I have good evening, everyone. Myself, Tilak Raj. So, I'm presently with the automotive industry of manufacturing brand, so which is River Mobility, and we are also a top 10, one of the top 10 in the leading automotive brand. So, it's my pleasure to address the gathering here on the topic of electric vehicles. And today, I have splitted my sessions like six parts, which you will be seeing it here. The first one is to understand the EV and hybrid electric vehicle technologies. So because people generally thinks EV means it's a battery motor. It's right, but there are some technologies inside which no one is familiar with or no one is aware of it. So I'll start with that awareness and what is the standard and presently where is the EV market and going beyond with that. So first, what is an EV and a hybrid electric vehicle and adoption of EV and hybrid electric vehicles. So now the difference between a hybrid and a EV. So hybrid is any two sources. It's not only petrol or an electric. Any two sources. Can it be a petrol and a solar and also vice versa. Any terms. A hybrid is a sense which conserves energy. Likewise, we have multiple hybrids in present day-to-day life, even in ICE engines. And electric is completely without any fossil fuel, which is using a complete EV as a battery as a main source or any other battery related driving technology or a drivetrain. Next, a hybrid electric vehicle powertrain uses a battery, a motor integrated with an ICE engine, which can regenerate the power. So, to be very familiar with a kinetic energy, so regenerative braking systems. So, how the kinetic energy is being reversed back to the battery. That is a very basic system which brought into India with Maruti Suzuki SHVS technology, smart hybrid vehicle by Suzuki. So you would have seen Suzuki vehicles with the badge SHVS or Ertiga or Ciaz, every vehicle on the back end. So it means a smart hybrid system where you're mostly the people or a consumer is wasting the energy is braking and during the tight traffic situations where you accelerate, you not even move 100 or 200 meters instantly, but within 50 meter you apply the brake. The fuel consumed is powering the motor to push it forward, but you're stopping it suddenly due to the signal or tight traffic situation. This instantaneous RPM or the peak power and applying sudden force. When you apply force, the clutch and the flywheel, which rotates at the peak RPM, that is converted into electrical energy. That is called kinetic. So, sudden stopping force, which will regenerate. So, this is being used with Maruti vehicles, especially, and slowly vice versa, we have brought up in all the EVs. Next, EV is nothing but a Tesla. So, for a easier familiarization, it's a battery vehicle which is completely on a battery, and thus it has a mechanical components as well. So, suspensions and the steering component. It's a partial mechanical where we have implemented MTPS, motor assisted power steering system, electrically controlled power steering system, which senses the movement of one half rotation and converts into two or three rotation to a magnetic field. And thus, your recent technical vehicles, when you turn your steering just a slightly, it will turn your wheels with more than a 20 to 30 degree. This is because of the MDPS and the electrical assisted power steering system, which is vice versa, or in day to day life every vehicles are using, and now the technologies are improving where we are going with drive by wire system. So the emerging system is from the mechanical component partially using an electrical system to assist. Now it is a wireless transmission. Now you can see bikes, KTMs, and many cars are having throttle pedal or accelerator pedal with a cable, without a cable. It has a sensor. It just acts upon the resistance, how much the pedal is being pressed. And now eliminating the mechanical links, which makes the car lighter or the bike lighter, and to eliminate mechanical links, now the electrical values are very accurate, as well as it is efficient and instantaneous. That is how you achieve the speeds in day-to-day vehicles. The TVS Apache RTR is Racing Throttle Response. The RTR stands for. How the throttle response is, when you give a throttle, immediately the signal is being sent. If it is a cable, there will be a lag or there will be a mechanical tension which elongates the table and the communication delays. Now there is no delay when it's electrical. That is how the industry is moving towards. And this is a short familiarization on the powertrain or the fuel efficiency and the engine emission levels and the price ranges. So hybrid, you no need to charge, specifically on an overview, and electric, this is a charging and a range constraints. So range anxiety is there in still in the EV because of our Indian environment, and there is no structure of EV charging station. The ecosystem has to be developed. And not only hybrid is only with electric and electric and petrol. There are biodiesels. There are electric, one among them, ethanol fuel, hydrogen fuel cells, natural gas, and propane. So propane is readily available gas which has been used also. Natural gas, now slowly we are being green gases. We are been using it, and significantly it is reducing the cost of petrol or the cost of petrol and diesel. And hydrogen fuel cell is a developing system which the leading markets like Toyota is working on, Hyundai is working on, and that still is a future. And biodiesels are renewable, which has already been used, and cooking oil are with the biodegradable materials and the natural gas. Ethanol fuel is also been from the plant materials and the corns. So there are many alternative fuel, but since the availability, we go with electricity because India is the third largest leading in lithium ion production. So abundant of lithium ion is there in India. So that is the reason world is focusing on electric vehicles and the battery development in India rather than others. Also, the life cycle. So if you have a hybrid, the expected lifetime is not more than 15 years because either you have to replace the battery, which costs you nearly half of the price, and that has a ownership cost also. But still, during the ownership, you are not immediately or in an interval you are spending it. It is at a one time where you replace the battery. So comparatively, the cost is similar owning an ICE engine and the hybrid, but the cost of maintenance of hybrid increases in the insurance or any technical aspects where the electrical components are not covered, or a small defect in a electrical component will lead into a major work related major issues in the vehicle. So disadvantages are like discussed: cost, economy, and now the insurance rate. And the hybrid vehicle fuel efficiency are also very minute slack in that. So on a combined, you get BMW i8 is a vehicle which gives you a sports car, gives you a 48 kilometer per liter mileage. A Toyota Hyrider which gives you more than 28 kilometer per liter, and some there is a customer who has reached, and it has published by Toyota also, he has got 35 kilometer per liter on a hybrid technology system. Wherever you are in a slower speed and braking, the hybrid technology retains the battery, and when you are moving at a slow speed, the electric motor assists in moving either rather than using an ICE engine power. So combinedly you can get a mileage significantly higher than a normal ICE engine vehicles. So that is how other advantages, equally it has a disadvantages as well. So it depends on the people who goes for the hybrid or an electric. So it is purely on the usage and the needs. So in this, there will be a few questions which we will be addressing at the end of the session, like are the hybrid cars good? Or you will come to know these questions as you go through these slides at the end of the session. Participants can make a note of this. And in the end, if you have any doubts on this, if you have still not got the answer, you can put it up to me. I can give you a clarity. Are hybrid cars good for long distance? Or how long do you hybrid cars takes a charge? Do hybrid cars turn off and stop? Which is cheaper to run? What happens to run when a hybrid car run out of fuel, and vice versa? How long it can go without a gas? What speed hybrid uses a gas? What happens when hybrid runs out of battery? Do hybrid needs lots of maintenance? The last question has been answered. So hybrid cars is also a maintenance required vehicle where you have an ICE engine, but a slightly lesser because it is the duration of your service intervals are higher compared to your normal ICE engine vehicles. So is electric the future or a present? It depends upon the adoption. So if you see requirements of a consumer, the first thought comes as a cost. If you or me a consumer, when I go to buy an electric vehicle, I think about the cost, how much I'm going to invest on. What is my charging time? If I buy a vehicle, how long should I put it on charge? And what is my battery if I put it on charge? Then if I run out of battery, where can I charge? And then I will come to the vehicle type. So this is a requirement in the consumer mindset. So anything, let it be a mobile phone or anything, the people thought is what is my cost I'm going to put it, what is the charge it is going to takes, and what will be the range it is going to deliver. So this comes into the customer aspects. If you go to the compound annual growth rate, so in 2017 to 2022, compound annual growth rate of electric hybrid vehicles have been grown to 13.4%. The adoption has been increased. You can see the adoption compound annual growth rate in electric vehicle market globally. And Indian electric market 2017 to 2025, it has 34% it has grown. You will not trust me. I took this 2-3 years back. It is almost 2 years back I took this, and now it is the same. So that is a prediction. We thought how the electric will grow, and now it is there. So 30% of the Indian market is electric now, and that is how we are progressing. And this is the consumer thought we saw. But when you go for the fleet manager, which is a manufacturer, so the manufacturer aspect will differ. If we are going to build a vehicle, what is the range we are going to define for it? Then, if I'm going to give a vehicle with a 100-kilometer range, what is the size of the vehicle? Surely it should be a two-seater or a one-seater bike only. If I'm giving a vehicle of a 400-kilometer range, so I should think about a larger size vehicle. then it's 100, then I should think about the size or type of the vehicle, because the battery depends upon the weight ratio and the loads and external components I'm going to add on the vehicle. Surely the battery range decreases. So I should have a battery which can deploy 200-kilometer range. After putting all the chassis, structure, everything, it should still deliver 120-kilometer range, because the remaining goes as a loss, friction loss, mechanical loss, weight loss, multiple are there. So excluding the losses, it should deliver. And the infrastructure I'm going to give. If I'm going to give a 120-kilometer range and it's a scooter, surely I will think about the infrastructure later, because I'm going to give them a charger where they can charge it at their homes. If I'm going to give it as a commercial vehicle, surely I think about the charging infra. Then, if this is the structure, what is my price I'm going to set in the market? And then I come for the charging time. If I'm giving a vehicle which can deliver you a 200-kilometer range, and it's a four-seater vehicle, and also it has a charging infra, and I give it in a minimal cost, customers are least bothered about the charging time. So that is how the fleet management thinks. So this is the reverse calculation. And Indian market 2021 to 2022, this was the growth. Q1, Q2 sales and electric two-wheelers, electric passenger vehicle, electric commercial vehicles. So you can see 2023 has abundantly grown 2 lakh of vehicles combined to put all together. In 2022, it was only 10,000. In a year, two-wheeler were sold 1 lakh 30,000 two-wheelers were sold. So in a Q1 sales. So that is how the demand increased within a year on the EV front. So this is one. I will share you one more. Types of hybrid vehicles. So far we have seen what is the structure or what is the adoption of EV and how the market is growing, how the demand has been increased. Now coming to the types, getting into the topic of hybridization and the electric vehicle technology. So far, we have seen the industry standards. Now, ICE engine plus an electric motor is what people now think about hybrids. In hybrids, we have conventional hybrids, a complete hybrid, and a plug-in hybrid, and all electric. So all electric is also a hybrid because it has a regenerative system which conserves the energy. So these are the types of hybridization. If you see a conventional, which is a complete petrol car where it also uses a regen system and it runs on consuming a fuel, fossil fuel, and it has emissions. And if you take hybrid, it runs on source of energy which is single source, which is a fuel, but still it has an internal battery which is a minor secondary source. The major source is the fuel, and it has lighter, less emission compared to a conventional. If you go for a plug-in, it can either run on a fuel or it can also run on a electric. Where the fuel is used as a secondary source, the majority runs on the battery when you go for a plug-in hybrid vehicle. And the emissions are still there, which is lesser compared to the conventional and a hybrid. And electric is obviously it's completely no emission, zero emission vehicle, and it runs completely on a battery. So hybrid drives. So hybrid drive is nothing but a motor in all the typical electric, not an electric, ICE vehicles. So let it be a two-wheeler, let it be a four-wheeler. Everyone would have seen a alternator, which is a AC motor. How we are able to drive our vehicles for 3 years, 4 years without replacing a battery, even in a two-wheeler and a four-wheeler, because of the alternative current. So the alternator regenerates the power, or it transfers a mechanical energy into an electrical energy to the battery. So this alternator is being used very years and years in an automobile to charge the batteries in the vehicle. So in two-wheeler, it's a magneto coil, and in four-wheeler, it's an alternator assembly, which has been fixed on the side of the engine and mounted with pulleys and well connected to the flywheel. So, how this alternator works? It is very simple, like when your vehicle runs, and it has been instructed, like people will say, don't turn on your AC or music system and with the car engine turned off. So it means it is a DC current you are using directly from a battery. if you start it and use, the battery does not get drained. The alternator gets charging, keeps the battery charging. This happens only when there is a standard rotational motion, at least a minimum required RPM. Whenever you people start your bike or a car, your engine RPM is at minimal, which is 1000 or less than 1000. So 900 is a standard RPM you get, and in that the alternator keeps charging it. So that is how your battery gets charged. And this hybrid vehicles uses an alternator in a larger frame, which is directly mounted with gears on the flywheel instead of a belt drive. So now there is a higher wire turnings and higher coil windings, which generates more power directly from the flywheel while driving itself, because the car needs a higher charge. So which vehicle is better? So hybrids, plug-in and battery electric. So all three have a different pros and cons. It depends upon their needs. So how you are going to use your vehicle? How are you a one vehicle or a multi-vehicle family, and how far do you want to go on travel? On these terms, you fit into the three terms, which is hybrid electric, plug-in hybrid, or a battery. So that is how the direction goes. So hybrids, we see three types of hybrids. What are the types? Based on the transmission of power, or the power transferred from the engine to the battery or battery to the wheels, vice versa. First, on the classification on powertrain, both are same, but there are 2 degrees of classification. Based on the powertrain arrangement, we say at a series, parallel, and a split or mixed hybrid. If it is a hybridization term we are speaking about, we say as micro hybrid or a mild hybrid, plug-in hybrid, or a battery electric vehicles. So these are both are similar, but in the terms of powertrain, these are the split array classification. Based on the hybridization, these are the classifications. First one, a series hybrid. In series, the orange color is your engine, the yellow color is your transmission, and blue color is your motor, and green is your battery. Series is nothing but everything is connected in one line. So when the series hybrid engine runs, the engine power is transferred into the transmission will rotate the motor, and the wheel is rotated. When you need a assistance in power, the battery also powers the motor, which assists the axle to rotate. Also, when you are braking, the transmission shuts or disconnects the clutches from the engine, but still the wheel rotate. That rotational motion is transferred to the motor. That time, the motor without power becomes a generator, which transfers the power back to the battery. This is a series system. Parallel hybrids. In parallel hybrid, you have a motor in between your transmission and your engine. So when the power flows from the engine, we are using on a fuel, the engine will power the motor, and motor will connect to the transmission, and the vehicle runs on a fuel. Now you are running out of fuel. That time it disengages the engine from the motor. The motor rotates the transmission powered by the battery, and your vehicle runs on electric. So this is parallel hybrid. Series and parallel, you have a split or a mixed hybrid, where there is a power split device which converts a vehicle from a complete hybrid system, or a mixed hybrid system, or a parallel hybrid system. So there is a split device which uses in commercial vehicles. You can see heavy vehicle trucks on tight traffic situations. The trucks are able to move freely as a four-wheeler. No, like a passenger vehicle, the heavy trucks are moving, the cement lorries. How it goes? It has been transferred, and the power split device helps the engine to shut off, and the conventional energy transferred to the battery, sourced by an inverter, which steps up the current and rotates the flywheel with a alternator fixed mounted over the flywheel, which acts as a motor. We call it as a integrated system, motor cum generator system, MGU. So motor generator unit we say. When it powered, it becomes a motor. When not powered and rotated mechanically, it becomes a generator. So that is how this split device works. And on the hybridization part, you have fully hybrid vehicle where you have seen in the initial slide, like gasoline is the main power and battery is the secondary power, where you cannot charge your battery externally. And plug-in hybrid is something where you have a battery can be plugged in. Also, you can fuel the car. So two sources can be filled from outside. And an electric vehicle is a complete battery vehicle. So on the technology front, so there is a video which you get, or if you want a clarity, you can go on online, and there are videos which elaborates how the electric vehicle has been mounted to the electric motor is mounted to the flywheel on a hybrid vehicles. So how it assists in pedaling, or you can see Maruti Ciaz is a good example because they have integrated two batteries in the vehicle. One is for a completely hybrid system and one is for a complete internal auxiliary lights and interiors. So now how this works is when you are stopping in a signal, the countdown starts, and when your gear is on neutral and you are stopped in a signal, the vehicle speed is 0. The count starts internally at the ECU, and at exactly if you are stopping for 100 seconds, 120 seconds, sorry, and the car automatically shuts off. And the engine completely shuts down. And but your AC remains working. This is in hybrid system. When you are moving from the traffic, just you have to press your pedal, the car again starts automatically. This is assisted by a hybrid system which uses a secondary battery to start the engine and stops the engine to conserve the fuel. And also it assists the flywheel in climbing up or steep locations or in sometimes of push power where you needed a higher load. So how it assists is you have seen good example is your government buses. On a signal after stopping, if they want to take a top gear, the accelerator will be pressed so hard for the engine to slowly struggle and move. But nowadays that is not required in hybrid system because the electric motor also rotates the flywheel, making the engine to reach its higher RPM at instantly. So there is no high amount of fuel is required to be consumed to move the vehicle. So now two energies equally works together to rotate the flywheel, and then the vehicle easily moves towards forward, as well as on commercial vehicles while climbing up steep hills or higher inclined surfaces. So this is a 3D diagrammatic representation where a series hybrid where engine and an electric motor works together, but the wheels are rotating through a battery powered, and also the battery is being charged. And plug-in hybrid where you plug your vehicles and you get a 15 to 20, 15 to 50 miles of range. So on a instantly during plug-in because they use DC charging and a fast charging stations. And parallel hybrid where the drivetrain, you can see the wheel in dual colors where it runs both on gasoline as well as electric. Battery electric is obviously known and which is familiar, which completely runs on a battery power. So there are few terminologies on electric, which is EV, BEV, regenerative system, hybrid, plug-in hybrid, neighborhood electric vehicles, and extended range. So neighborhood electric vehicle and EV is typically we would have come through this, but we have not known that this is an EV. You would have, if you are in Bangalore, you would have seen Yulu and small cycles which are electric, which goes at a maximum speed of 35 to 40, and it is a one single person. It looks like a cycle. So those are neighborhood, which is a limited speed and limited range. Coming to this regenerative system, I want to emphasize. I want to explain it in deep, like how it works actually in EV, ideally, how it helps in EV system, the regenerative. So far, scenario, I'll give you one scenario you can imagine on. Think you are driving on a stretched road, which is an empty road. When you are accelerating your bike at a higher speed, when you see an empty road, obviously people will accelerate. Now, at 50 or 100 meters, you saw a signal, but your bike has reached 80 to 100, and suddenly you saw a signal. It's not been at least 10 seconds, less than 10 seconds only you have given an accelerator and reached 100, but at 50 to 80 meters, you have a signal or someone crossing in front, you have suddenly stopped the vehicle. In that 10 seconds, the throttle you have opened, it is fully opened, which is 90-degree, the throttle has opened. And the fuel it has let in is higher fuel. Now suddenly you have shut down the throttle. This fuel has burnt enormously inside and pushed the engine maximum. But the RPM also has gone higher. But you have stopped the vehicle. This fuel cannot be got back. This fuel burnt is burnt, but the engine, the energy wasted is wasted. You cannot retain it back. The same scenario, if you take it in an electric, you go on a stretch road, you again give an accelerator in an electric bike, the battery is fully, it has been at a peak power, it's consuming the battery current, the motor is reaching at its peak power, and you are moving the vehicle at 80 to 100 within 10 seconds. And when you saw a signal, the same scenario as someone crossing, you released your throttle, or with the throttle, you applied your brake. Here, this brake acts as a switch, which shuts down the current from your battery to your motor. That time, the motor will become a generator, which reacts and it transfer the kinetic energy to your battery. At that two instant, at least a 0.10% or a 0.05% of charge is sent back to your battery. That is how the electric vehicles, when you go downhill, or when you are deaccelerating, most of the EVs, when you leave your accelerator, you see a regenerative system blinking, because all the EVs are having high torque motors, which the regenerative system is sufficient for braking power and no need of external power to brake. That is why in the new EVs, whenever you apply brake, you find it very sharp, because the regen system is already slowing down the wheel through the motor and the belt drive or a chain drive or a gearbox. But still applying brakes, it stops the regenerative system as well as the vehicle at that instant. So that is how the regenerative is helping out in the electric technologies and electric automobile technologies. And one major problem for EV is the charging infrastructure in the country, where we are not that established one to have a charging station. There are range anxieties, and still there are people depending on fast chargers. Also, we have natural calamities like floods and everything. So, which cannot have a good charging infra, even if the planned charging infra, it will be outside the state or on a highway where it is not feasible for many localites like who are buying a two-wheeler. So only for a four-wheeler on a highway, the charging infra is good because it is kept on an elevated surface where it is not affected with flood or any earthing issues. But on a city limit, to set up a charging infra, it requires a lot of safety precautions. So on the charging front, you have three types of charging, which is level 1, level 2, and level 3. There are few types still more in deep in this. Level 1 is nothing but your home charges, where you plug in and you use your common electrics. And level 2 are something higher, which needs an external installation separately for that specific charging voltage, which is completely for your EV. Comparatively, it will increase your charging time 5 times than your slow charger. So that is a charging level 2. And charging level 3 is nothing but your fast charger, which is a DC current charging. And this is a faster charging method which needs certification and infrastructure. In level 1, you get a 2 to 5 per hour. If you charge 1 hour, it will take only 2 to 5 miles. It is into 3, where you get around 15 to 20-kilometer range only in 1 hour, which is a slow charging. Level 2 is nothing but a fast charging, which fleet management is working on, and it is simple, 3 times faster or five. Sometimes it is 4 times faster than your level 1 charger, which needs a installation at home, and it needs also to be authorized by the manufacturer. Level 3 needs a charging station exclusively, which is a DC charging station like your fuel's bunks, and it is multi-residential and it needs a charging authority to be signed by the state government, and there are some rules and regulation for that. But for a level 2, you don't need any certification from the government, where it is on your household current where you install it separately. The other technology is onboard charging. These technologies are used in McLaren Speedtail, Ferraris, Bugatti Veyron, and other supercars where you can see this. So many supercars like Ferraris, McLaren Speedtail especially, they have a additional electric motors where the last year the government has initiated a rule supercars will be going hybrids, and few of the supercar manufacturers are running with W16, and Porsche has come with an 18 cylinder, and there are new revolutions going on. But still, most of the supercar manufacturers have released their cars with a hybrid drivetrain system. In that, to charge their vehicles, there is no external charge. You will have an onboard charging mount at the front or underneath the car, and you have a camera to access it, where your car should park on the charging board, then the charging happens. It is a wireless transmitting. So this is also going in a trend, which is in upcoming generations will be seeing an onboard charging or a wireless charging stations for commercial vehicles, especially when you will have a commercial vehicle setup where the underneath the floor will be a charging line, and when you park your vehicle over there, it gets charged. So there is no wired charging system. That is the revolutions on the future. So you have a BMS, onboard diagnosis. So onboard diagnosis is something which came in BS4 technology as well as in BS6 in a higher manner, even in two wheelers. It's a diagnosis like how human health is diagnosed. You can diagnose your vehicle while operating itself, which particular component has failed and what is the parameter. It depends upon the various level of security system. Like a manufacturer can see the coding and the optimal working temperature of an injector or a thermal sensor, or what is the RPM, or what is the signal from the CKP sensor at the engine. So vice versa, it depends. For a customer, he can see what is my fuel level, or what is my driving score, or what is the temperature inside my car. Can I start my car and turn on the AC while when I'm working in office, so that I before I reach my car gets cool. So these are all the various revolution or the growth which has come now as a BMS, battery management system, in a EV, where a EV owner can see his vehicle's leftover charge, or when it is charged, it reminds him when it is full, so that he goes and disconnects it. And also, it has a geofencing, it has theft system, anti-theft system. If anyone is trying to move his vehicle, it alarms. So vice versa, it has developed from a diagnosis, onboard diagnosis system, to the battery management system now, which you are seeing. And also vehicle communication control system. Whichever we saw in an ICE vehicles, now it has grown up in a deeper way, where you have electrical control, power inverter, traction motor, a DC-DC converter, and a charger. Many people will not know why we are using a DC-DC converter. So in EV, we have a battery which is 3.4 kilowatt of battery, so which supplies the power to the motor, and the BMS handles and the MCU handles the power supply to the motor, and the BMS handles the power transfer from the battery. So these are all controlled. But still, in a typical bike or a scooter or a car, we have horns, we have indicators, we have small electricals which is 2 volt, 5 volts, or 10 volt. The entire 3.4 kilowatt of battery cannot be supplied. So this DC to DC is a step down current which reduces the current based on the requirements and transfers it to the required component. Otherwise, it can have a short circuit or the component failure because of the high current voltage. Also, you have a safety protection system which is inside of a battery management system. Everything, the typical and the costliest and the very technological thing in an EV is a battery. So the main thing is to protect the battery. So the safety system protection will be in the battery management system, which keeps on monitoring the current, the voltage, the temperature of the battery. Once it sees the battery temperature is rising, it sends a signal to the electrical control, and the data acquisition also sends a signal to the user interface that the battery temperature is high, which you see on your screen or your odometer or your TFT display. The electrical control will go to the hibernation mode, or it will go to the eco mode, because it will restrict you to give a high throttle, not to consume more power, because the battery's power temperature is rising. We cannot discharge more power from the battery. We have to give rest to the battery, and your power has been controlled by the BMS. Once the thing comes into a normal optimal working temperature, then it allows the user to again use the battery or the vehicle as required. These are all the smart system which works in the vehicle control system. Now, on the drawbacks, so far we saw what is the adoption, what is the EV structure, or what is the hybridization. Still, people think, is EV and waterproof? If I buy an EV, it's a battery and a motor. Can I drive it in a waterlogged area? So it's a battery waterproof. No, shall I drive it? The question to you people is, if your mobile phones are IP68 and IP67 rating, can you use it under the water for 1 day? No. And there is a standard by the RI for an IP68 rating. Ingress protection 68 or ingress protection 67 is only for 3 meters and half an hour inside the water. So that is a standard for any EV. So it's not I can submerge my vehicle and it can stay inside the water. It is IP rated. Nothing. So this is the misunderstanding which a consumer level has understand. So the main thing is, every manufacturer test their electric vehicle up to a certain safety mark, which is not above your wheel. So only till the wheel level the vehicle will be submerged and tested, for which there are electrical components, there are thermal management systems, there are heat HVAC system which evacuates the heat from the battery chamber, and there are motors which does this HVAC support, which can be affected, and there are air conditioning system which can be affected in case of a four wheeler. So there are safety height at which you can test it, and the time duration you can test it. So people thinks, if I buy an EV and it's been flooded in my area and vehicle is in the water, still I can drive it. Not at all. Your motor controller unit, your couplers, and your battery management system, it resists the water to go inside. There's a water protection layer inside your battery, but it's still, as per RI, it is 3 meter and half an hour. More than half an hour, it's not recommended. It could have been affected. So, and also in submerged in water, particularly salt water, means you can expect a short circuit, because the salt water has the corrosion nature, and which will have an impact on your sockets, as well on your coupler windings, which can trigger your circuits in the electric vehicles. So, for example, your motor MCU is there in the front, which is connected to the motor. Ingress protection 67 and 68 can resist the water entering into the couplers for half an hour. But more than 3 meters, the pressure will be high, and there can be water entered into the couplers. So this will affect your circuit pins, and it can have a chemical reaction which may cause a short circuit. Also, if you go on explosion risk, what will happen? First, starting with the impact. You can see crash test of multiple EVs which all the manufacturers are highlighting. If you have a crash test done, first your car will crash and there will be penetration. Now thinking about the battery. So if there is a crash, so surely the battery has been crushed or the battery pack is deformed. Maybe it could have been. So if it would have deformed, so the battery is penetrated or it has been bent. Okay, maybe it can have a short circuit, an internal short circuit, or it's due to which there can be a leak of charge or overcharge. Due to overcharge, it can have heating, which will have, if it is crushed or penetrated, it is a mechanical abuse which will deform your battery and separation tearing, which can cause an internal short circuit. Or else, if there is a overcharge or discharge and internal short circuit, it can have an electrical abuse to your battery, which will also have an internal short circuit in a major way. When overheating due to this impact can also have a high temperature, collapse of the separator because there will be grids separating the battery cells, which can also collapse an internal circuit. These are your anxieties when it comes for an explosion risk on EVs. So and if you see the fire cases of a car, fire by vehicle type, car fire types, hybrid cars fires per 10 100K sales are 3,000 and gasoline are 1,000. Electric is very, very least compared to the other two. On every 100K, which is nearly a 1 lakh, you see a very least in fire accidents in electric. It's not much, one or two. That is why you see one or two incidents getting very much famous of a electric vehicle having a fire. So because people have never seen, one or two gets very famous because that is the actual thing they are seeing, a EV getting fired. And most coming to the third images, people seen Ola Electric getting fired or any other EV scooter getting fired. This is due to heat ventilation system. People uses overheating, which consumes or absorb heat materials under their seats, especially ladies. And we have seen, in my experience, I have seen in scooters, especially you have seen a Vespa scooter or an Activa, where they would have given a vent below your foot on the side, on the front side. So when ladies drive their saris or their skirt, which blocks the passage, will have the engine overheated because it is not allowing the air to pass through it. So the engine is not getting enormous heat dissipation. That will get heated, and the things under their seat will obviously get heated. So this is also one of the concept. People are sticking their stickers or some kind of stuff which they are blocking the passages will have overheating. And also not to recommend on overcharging. Many people do not have proper earthing at their residential areas. So earthing issue also causes trigger in your electrical fire incidents. Has everyone seen this bike, Kawasaki? So this hybrid technology was developed by Kawasaki, where they were working on a powertrain which can assist the engine as well as it can drive the vehicle in electric. So this means this Kawasaki bike can run completely on battery, also can run completely on ICE engine power, which is fuel powered also. And some cases it can run in both. It's a hybrid electric vehicle. How does it works is, so there is a video link after this session. I can share it across through the group. You people can have a view on this video link. So how it works is the powertrain will be run on an electric source where you can see the motor. The engine is inclined, which is inclined engine, which is an inline 3-cylinder, and a motor which is at the center. The motor and the engine have a common output shaft sprocket. So now the motor can also drive the output shaft. Even the vehicle engine can drive the output shaft. So when the engine is running, the output shaft becomes a generator which transfers the motor to charge the battery. And when it is running on the motor, the output shaft disconnects the engine flywheel through the clutch assembly so that the pistons are not moved when the vehicle is running on an electric. So this is how it splits up. And the complete setup looks like this. You have a typical output shaft and a sprocket, but a motor also inclined to the engine, which has been at the bottom. This was the type 1 of ultraviolet which you are seeing now. So it is an Indian made electric super bike, we can say that, because its top speed is 150 kilometer plus, and it is having a top range of 300 kilometers range on a higher variant. So this bike is ultraviolet F57, which was 150 plus of top speed. And now on a single charge, the base variant can go up to 150, and you have various models which on a top variant will go up to 300 kilometers. You also have a Harley Davidson Livewire, which is an electric bike. Still, it has a range with it has a range with 80-kilometer max city and highways, which is a limited range, but still people go on a comfort, and still there are EVs with a lesser range. And now I'll go with the day 3 one. These are the growth and revolution happened, and there are still companies working on with a hybrid system, also the full electric powertrain system in automotive especially. So that is why you are seeing more adoption in India for electric rather than other European countries as well. And China is one of the major contributor for EV, where they are having major EVs, and you cannot see any ICE engine vehicle, and they prefer cycles instead. Now we move a step forward. We have seen typical two-wheelers, four-wheelers, commercials in a electric and a hybrid technology. Have you seen any hybrid system in a Formula One? So Formula One are having e-formulas, which is electric formula racing. The regenerative system alone helps 60% of the car is driving with regenerative system, because in Formula One the peak power it reaches at every corner, the rider reaches at 260 speed, 260 miles per hour. Sometimes at they constantly maintain 150 plus miles per hour, and suddenly braking at that particular instant, your regen system will regain the power as much as possible. So 60% of your Formula E is driving with regenerative braking system. And Formula E is emerging one, and now we have seen multiple the F1 rules and regulations have changed. They are changing there is no more spoilers, and now it is an active aerodyno. We had a drag reduction system. Now it has gone as an active aerodynamic system, which works as per the requirement. So that was a new growth in a Formula One system. Now motor generator technologies. We call it as an MGU. Abbreviation is motor generator. People have seen this, but you can recognize it easily now when I say TVS XL100 and Yamaha Ray, Activa, any scooters, and TVS Rider. So many bikes are there. If you have seen this XL100, which is a very easy vehicle which everyone can see, XL100, you have seen iTouch. So it was launched by TVS first to the market. It is patented by TVS. So since I work there, I can explain it in I can say it honestly. Like we introduced it to be the first in market system and patented by TVS, which now multiple companies are using it. The technology work is you have to reduce a battery usage. Where XL100 is a customer whose vehicle is his bread and butter for day. He's a breadwinner of the family. He has to drive the vehicle, and battery being a self motor, and you are cranking the vehicle, battery consumes fully 12 volt on every self, and if your vehicle is not starting, the battery also get weaker when you are trying to apply yourself. This motor generator system unit transfers your magneto into your self motor. So we eliminated the self motor in the vehicle. Now When there is a magneto-coil, obviously every people would have seen when you in the left side of your engine case is removed, you see a magnet and a rotor and a coil, a stator and a coil system. That's a permanent magnet and a stator coil. Now this acts as your self motor. Now don't need of self motor. It is directly linked to your flywheel. Now what is this ISG system does is when you press your self switch, the power from the battery directly goes to your magneto coil and this energizes. Obviously, the magneto rotates only forward, not in a reverse. It's blocked by one blade clutch. Now, the stator coil gets energized and becomes a electromagnet. Now, it moves the permanent magnet forward. And when you keep pressing your self start switch, the battery sends more power to the electromagnet. On a high charge, it cranks the flywheel and starts the engine. Once you release your thumb from your cell switch, this electromagnet gets disconnected and becomes a generator. This is what we called as a starter generator system. So that is how the MGU works. So this is how nowadays you see many of the vehicles have, you can see Yamaha Ray hybrid. This is a hybrid in that. You can see a TVS Rider hybrid. This is a hybrid where you are conserving your power. With this, 30% of your battery is saved. You no need to press self every time. A self motor is not there. Your maintenance is reduced. So whenever your vehicle is stopped, it shuts down. The engine turns off. And when you press your brake, any one of your brake, the power from battery goes to the magneto and starts the engine automatically. You cannot feel the self motor working because it's the engine itself starting automatically. There is no external motor cranking the flywheel. So vibration is reduced, a component maintenance is reduced, and the battery has been lifetime has been saved. So that is how MGU works. So typically, like anything electric motor, it's a mechanical energy converted into an electrical energy. Sorry, electrical energy that has been converted into a mechanical energy with the power system. And we have a generator that converts a mechanical to electrical. So at times when the motor is not supplied with the power, like a magneto, when you release your thumb, it freely rotates. That mechanical energy is converted. That is the generator. And an electric is nothing but when supplied an energy, electric current is converted into mechanical. So armature core is for holding it. Obviously, these are the standard terms. And in AC and DC, we have different types of motor used in the industry across, especially this DC stepper motor. There are various motors, but this especially DC stepper motor has an important application. So AC motor is we have been using it widely. All the electric vehicles uses AC motor, not a DC motor. Why means AC is is lower cost and uses less current rather than a DC. If you are having a DC motor, you cannot have an extended range or a higher range electric vehicles. AC current only gives you to reach higher ranges. That is why every EV uses AC motors and DC motor. So especially as I said, this DC motor.
Sorry to interrupt. Can you please
Yeah.
repeat the last point? You just have mentioned AC current and DC current regarding just last point.
Yeah, sure. So mostly in electric vehicles, people thinks it's a speed. Electric vehicles has to move at a higher speed. It has to use DC motor only. It's not like that. People and we manufacturer uses AC motor only in all our EVs because it has a fluctuating current as well as it is efficient rather than DC. Also, it can have extended range compared to a DC motor fixed vehicle. A vehicle with a DC motor will have a short range but a peak power. But a vehicle with a AC motor can reach at higher range and it is also easily controllable. So DC you can have only one way, maximum current or a no current. But in an AC you can control the motor speed. So that is why most of the electric vehicles have AC. Electric vehicles have more AC motor, where you can control the vehicle speed and you can play around in the technologies. So it is highly controllable.
Okay. Thank you, sir.
Yes. And DC motor especially, if you see a BS4, BS6 technology where we all move to EFI system and there is no carburetor no more and there is no choke concept. What happens to your vehicle in the morning time when you start it in a cold start? You start the vehicle and you put a choke or you accelerate and keep it at a maximum RPM to make the vehicle warm up. Now, in BS6, you will not find it. In BS6 vehicle, at a cold condition, after a long stop, when you go and start your vehicle, the vehicle RPM automatically rises. How does it mean? This stepper motor. This does your work electrically inside. So when there is an engine temperature sensor which senses the temperature through the MAP sensor. MAP sensor is mass airflow, which has the mass of the air flowing into the engine. Also, it is a temperature sensor integrated. Also, it gets a signal from the O2 sensor, which is your oxygen sensor. Oxygen sensor sends a signal to the ECU. What is the oxygen level in the exhaust? If the O2 sensor finds a lesser oxygen, that means there is no air flowing into the engine. That is no sufficient rich oxygen inside the engine, and there is a requirement of higher oxygen. Now the MAP sensor will open up the intake, that is the choke passage, which is this stepper motor. Stepper motor, what it will does is, it will not open the throttle because the throttle is the rider's control. It is a manual one. It will have an integrated passage like your choke, which we already had in a carburetor. That passage will be closed with 6 to 7 threading of a screw. Now the stepper motor's beauty is you can precisely control each and every 1 to 2 degree or 10-degree direction forward and reverse. So now when this signal is received to the ECU that there is no rich oxygen and there is no less number of air going into the engine, also the temperature is very less. Now I have to warm up the engine. What the ECU will does is it will send signal to two actuators. One is your stepper motor, second is your fuel injector. Now the ECU with this signal received, it will send open the air passage little wider. That is the choke has to be opened, and also it will send signal to your injector to send inject high amount of fuel pressure. Now you can see your vehicle automatically rising 2000 rpm without you doing anything in the morning. You will wonder why it is happening. This is because of ECU detecting this through the sensors. And it is very beauty if you see how automobile is being grown. You can compare it with your human body. If your human body is your actual vehicle, think your legs and arms are your actuators. Your eyes is your sensor. Your brain is your ECU. When you see a dog on the road and it is coming to bite you, your eye sees that and it captures as a video or anything as a picture, converts into a data signal which brain can understand, and your brain receives that data. It is not seeing the actual dog. It searches for the data stored in its system. Yes, it's a dog. In this condition, it is coming to bite. And it sends the right signal to the correct actuator, which is your leg, to run away. So that is how the vehicle works in a fraction of seconds. That is how the beauty, how the ECU and electrical system works in a vehicle. So this is how we explain to all the very minimal technicians who's not even 10 standard or 8 standard, how they grasp the electrical systems. So for a easy understanding. Now, this is your motor and a generator, how we are integrating it on a flywheel. It is called as a motor generator. So generally, if you see in the slide on the bottom right corner, you can see it's a two-wheeler, ICE engine two-wheeler, where you have a left side magneto and a stator coil and a magneto, permanent magnet, and which has been mounted. And it is mounted to a crankshaft. When the engine runs, the coil stator remains and the magnet runs, and this creates an electromagnetic current which charges the battery, which is a three-phase alternate current, AC current, which will be sent to the RR unit, and the RR unit steps up the current and charges your battery. So this is how it works. Now, when you go for a higher end of a EV vehicle or a hybrid electric vehicle, you need these windings are not sufficient to charge the bigger batteries. Then we go with in a reverse way where your magnet will still rotate in the center, your stator becomes your outer surface, where in smaller engines you have the magnet over the stator. Here your rotor will be a magnet which is inside the stator. So now the increase of copper windings will generate more current, which will be sent to the inverter, which steps up the current and then charges your battery. So it is mounted on the dual mass flywheel. So over this, the magnetocoil, this is how the MGU gearbox works. This is an image from an Audi Q7. A hybrid technology in F1. Coming to the main topic of it. So when we speak about F1, we see power, we say performance, we say increased horsepower, and we say lighter weights. So these are the terms we know when we speak about F1. The F1 uses a kinetic and a heat energy system, which is kinetic and a heat recovery system. MGU-H, MGU-K, which is a motor generator unit. So far, I think you people know what is a motor generator. When supplied with power, it is a motor. When not supplied with power, it's a generator, which is freely rotating. And these everything, the beauty is, if you see, everything came from our simple ideology which we see in day-to-day life. Now, we call it as a powertrain system, power unit. Okay, so how it is, a power unit saves all the power. It's a battery, typically to say the energy saved from a kinetic energy saved from an heat energy is converted into an electrical energy and saved into the battery. And this is called as energy recovery system. The energy which is going waste, as I said earlier, in Formula One they drive at 200 miles per hour plus, and that time applying a brake wastes lots of fuel and lots of energy. That energy has been recovered. So this is called energy recovery system, which a Formula One car uses to achieve the top speed and win the race. You will not believe this. You will come to know. Now we have two MGU unit, which is heat and a kinetic integrated on a Formula One vehicle engine. First and third thing is your energy recovery system, which is your control unit as well as an inverter or a step up unit with a battery which stores all this energy and which allows the system to use this energy based on the requirement. It's like a mini ECU also. Now, when your car MGUK, like all the typical kinetic energy, like how we works on the vehicle, when you brake the vehicle at a sharp corners, that time the energy is recovered from the gearbox, that is your crankshaft, and that time when you apply the brake, your electrical clutch disengages, and that peak rpm, the car would have run around 8,000, 10,000 rpm, that peak moment, those time the engine becomes a motor. That in that engine there is a motor generator unit integrated through gears, which converts that rotational motion into electrical energy and sends to the MGU K, which is a kinetic, and MGU H. So MGU K is nothing but the normal which we are using at a typical electric cars or a conventional ICE engine vehicle. When you apply brake, the clutch disengages, but still your flywheel rotates at a peak RPM. That time, if you connect a motor or any gears to a motor, this mechanical energy will drive that motor. This is converted into electric. If it is in a typical conventional car, think about the motion or the speed at which then electric or a F1 vehicle flywheel rotates. That is converted into an electric energy and saved as in the ERS system through MGU-K. MGU-H. Everyone knows how the turbocharger works. A turbocharger starts functional above 2000 rpm. So about less than 2000 rpm, the pressure is not sufficient to rotate the fins of the turbo, and it will not recirculate the exhaust gases to EGR. And in a Formula 1, turbochargers are used to have the engine easily breathing. It's like a breathable system. So now in between the turbocharger, there is a motor connected. Ideally, in a turbocharger, what we have an exhaust and an inlet. In between, there is a shaft separated with oil, and that shaft one will be in suction motion, one will in exhaust motion. So in between that shaft, there is now a motor which operates electrically. The turbocharger now operates electrically whenever required. Now, how this helps in Formula One is, I think this graphics are not playing here. Ideally, I can share you this video as well on the link. I have made a note. So after the session, I'll share this video where it will elaborate you how it works in a visual manner. Now, the car speeds at a higher speed. Now, the kinetic energy we saw, a sharp corner came, a driver has braked the car, or he has applied braking. Now, the car speed has reduced. What happens when a car from 10,000 rpm comes to a 2000 and less than rpm? The turbocharger function stops. But here, in that speed, when the driver was reaching at that particular speed, you can see in the Formula One car, there is a passage above the driver's helmet. So that passage will allow air to pass through it, where you have this turbocharger. Now the passing air will allow the turbocharger fins to rotate. At that time, this MGU-H is some generator which will rotate and allow the motor to freely rotate and produces electrical current. In some village festival, you will see some children's playing. When you go move forward, it will keep on rotating. That is how it works. So very easily to explain. So whenever the Formula One car is going fast and at that particular speed, the pressure of air rotates the turbo fin, and that particular motion is converted into electrical energy, and this energy is also stored in the ERS system. Now MGU-K and MGU-H, so braking power. So MGU-K also, when the car is braking, it generates current from the crankshaft. Two energies are recovered now. What the car will do this? So this is how it works. So when the turbocharger, you can see the air flowing from inside over the head of the rider. The left side is your head of the rider, where the air enters and it goes inside this and goes to the engine. That time the turbocharger rotates. This is the motor which is in blue, which consumes, it rotates through the airflow itself and sends the power to the battery. And this is the red color is your MGU-K motor, which is connected to your crankshaft. While applying brake, the clutch is disengaged. The flywheel motion is converted into electrical energy and saved to your battery. So two energies have been recovered. Now, on a driver, think about the scenario. When the driver is going to the corner, the braking system is converted and saved. Now, till that corner he approached, the MGU-H unit, the turbocharger would have rotated and saved the current into the battery. Now, the usage comes. On the exit of the corner, you can see in Formula One car, the turbocharger will not stop. The beauty lies here. Now, the stored current will rotate the turbocharger electrically. So the driver will not feel lag. Instantly the car will take a speed. That is why Formula One car, after a corner, it reaches a speed. But our car or any diesel car, you have to reach 2000 plus RPM for your turbo to start rotating. But in a Formula One, the turbo below the functional RPM, the turbo rotates at higher speed electrically. So now you have saved that energy and using it to rotate your turbocharger. And the second energy, when you're braking the MGU-K, recovered the charge and stored into the ERS system. While overtaking at a higher speed, this MGUK, what it will do is this motor will also assist to rotate the crankshaft at higher speed. That is why the Formula One car can overtake another car at just one fraction of a second. Because there is another 120, that is 160 horsepower added. So all of a sudden this 160 horsepower comes with this battery backup. So this 33 seconds in a lap, they use this regenerative system. So the energy system which is getting wasted, at least it can be 160 horsepower is nothing but a point 0.5 or 5% of the car's potential. But that is also been increased because of this ERS system. So 120 peak horsepower is supported just for 33 seconds. So how that is supported is through this. Just after a corner, a slowed car, again the driver no need to press the accelerator hard. If he just pushes the car, already the turbocharger is functioning. It just sneezes out the engine and push the engine forward. Now still he wants to overtake that car. Now the second energy he can use it, which the flywheel is already rotating at 10,000 RPM. This MGUK unit now becomes a motor, and that will also assist in rotating the flywheel. That is how it goes. So have you seen like there is you can compare a tire which is rotating or a lorry tire in North Indian side and all, a lorry which is not starting, no, people will bring their motorcycle or a generator which has an additional tire. They will engage this friction, tire to tire friction. This tire will make the vehicle tire to rotate. With that the vehicle starts. So likewise this shaft is running already at a higher speed. Now the motor is also rotating the shaft. It becomes very easy for the car to reach 12,000 RPM in 1 second. So that is how Formula One uses a hybrid technology. This engine, which I am showing you, belongs to Renault F1. So Renault is using this technology. Meanwhile, Mercedes and all the McLarens, everyone uses in different terminologies. So this is the idea behind. The idea remains the same. The way they use this is different. And there is a graphical representation. I mean, I think this slide, it's not playing your graphic. So that is why I'll share you this exact video. And also like commercial vehicle, which I said in the initial way. So this is how the structure looks. The transmission, in between the transmission, you can see the armature. So now when the vehicle wants to run in a tight traffic situation, the clutch get disengaged and the electric motor only will rotate the transmission. The vehicle will move without any noise on the traffic. When on a higher speed on a highway, it is always recommended ICE engine or the fossil fuel power is better economical rather than complete electric. That time this clutch engages and the motor becomes a generator. That time this power will be sent back to the battery and it charges. So based on the requirement, the hybrid system functionalities, this is how this layout works in a commercial way. So it also has an inverter system which acts as a step up and a step down transformer. When power is flowing from the armature coil to the battery, it steps down and slowly charges the battery to have the cell balancing and ensure the battery is not damaged. And when the vehicle uses electric current from the battery, it steps up the current and gives the required high voltage for the transmission to run or drive the vehicle. So it is a Bosch system, which is a smart inverter, which is being used with commercial vehicles. So on driving, you can see on a highway, the thermal energy and an electric motor both will drive to give a combined power and fuel economy. And in a city tight traffic situation, the commercial combustion motor will not work, which is an ICE engine will not work. You will work on an electric motor. So with this, we are entering into the battery management, power control management, and thermal safety. Like first is your battery. there are different batteries ideally used in an electric vehicles. So we have seen only lithium ion. There were still more few batteries which have been used, like nickel metal hybrid, nickel cadmium, lead acid, solid state batteries. there were there are these are the typical batteries which have been used in electric vehicles so far. Lead acid battery is something earlier stages we used, and it is heavier, which adds weight to the cars as well. And thus, we moved on to a maintenance-free battery, which is MF. So, lead acid batteries still are being used, but still, it's not highly comparatively efficient compared to the maintenance-free battery or a lithium-ion batteries. And nickel cadmium batteries are still being used on rechargeable basis for a short-term power supplies. In factories, we use it for supporting the machineries, and also we'll be seeing this used in a remote control cars where kids play. So this is a nickel cadmium. And nickel metal hydride was a developed version of a nickel cadmium where it has a longer range, and as well as for a longer time it was being used, but still it was 2000s earlier stage, 2000 period, it was a technology, and then we moved into the nickel lithium ion. Ultra capacitors are also used in automotive various applications like jump starts, where you can see the power bank like material or a component. It's very compact, but it starts up the battery of a car. So it is having a high storage capacitors which instantly delivers a high current, and it has a short duration also. So it is not for an external use, and it has a 10 lakh time of life period where 10 lakh time it can discharge the current on in one instant. So this is also being used for high power charges, like as I said, jump starts or high power electric vehicles, or in case of commercial usage in factories where you have spot weldings, you have robotic arms which does the spot weldings in the factory manufacturing line. Solid state batteries. So this is for a limited usage. Still, EVs are using solid state batteries. We come across very low maintenance vehicle or a lower cost of EVs having solid state batteries. But this drawback is there is no heat dissipation. Either the batteries have a very lesser range, and which will be you can swap it, and also it has a heat dissipation, poor thermal management system in the battery. Lithium ion is the smartest one and the present technology where we are using it, and you can see it in various cars and two wheelers, four wheelers, trucks everywhere, which is the recent one. And India is the third largest of the lithium ion producer. So when you people come for EV, what will be the lifetime? So ideal lifetime of EV is 4 to 5 years because the battery degradation happens after 4 to 5 years. Average, on an average, it's not higher degradation, but still it starts degrading based on the usage as well. So batteries still last, but degradation starts from 4 to 5 years based on the usage at a slight manner, which is 5 to 10%. And after 8 to most of the batteries, even if they last to 8 to 12 years, less than 70 or 80%, you can see a drop in your performance where it's recommended to replace the batteries. So charging cycles. This particular concept, many of the consumers or many of the people doesn't understand in the EV ecosystem. New to EV or a new buyer of an EV does not understand the EV cycle of charging. They think when I put on charge, it should charge immediately at all the cells. It does not happen in that way. It's like a current flow. When you pour water into the bottle, the water reaches to the bottom level first and it evenly spreads. Even if you pour a water in an ice cube tray, it supplies the water to all the ice cube. Once all the ice cube bins are filled, then only it levels up. The same happens in a battery. The current flows and the cell balancing happens. That is why every manufacturer recommends or suggests 0 to 100 or 10 to 80% at half an hour, 10 to 80% at 3 hours. Above 80%, it depends upon the battery, depends upon the current which is flowing or where you are being plugged in at your home or a charging station, and it depends upon the battery's state of health, because even if it is the same vehicle, same branded vehicle, each battery differs upon the state of charge or state of health based on the individual consumer usage. So that battery management system decides at what flow of current I should accept and at when it has to be charged, allowed to be charged. So this happens at a slower rate after 90%. So to reach 100%, the cell balancing occurs and it takes a time to achieve 100%. This even happens in your mobile phones, but not significantly you can identify it, but still it happens. So lithium ion, the main reason people going for lithium ion is it is recyclable. After a while, a lithium ion is a sand. When you recycle it, when you split the chemical and metal separately, it's a sand. So on an aspect, it's even if it is sand, but still a chemical cannot go to the, even if it's sand, if you put it on a mud, if it is a mud, so it will have some chemical nature into it. So the recycling process have electrode, it will separate it has pre-treatment and hydrometallurgical process. So the spent lithium ion batteries, which is completely discharged, will go for a pre-treatment where the plastic metal shells will be dismantled and crushing of the batteries so that you can separate the plastic metals and chemical component. The cathode and the materials from the collector will be separated. The screening happens, ultrasonic washing will be done because there can be radiations or any other external chemical fumes, and then it goes to segregation of plastic, electrode materials, and aluminium, ferro material, and copper, everything. Then it comes to a hydrometallurgical process where in organic or inorganic acids, it goes undergoes a treatment where it becomes as a raw materials, and chemical and deposit solvents are being extracted out, which is not required. Then you get a raw material of new metal, a chemical product, and separate metals where you can build a new lithium ion battery, which can be used as a raw material. That is why they go for lithium ion. But still, we are consuming and we are taking the lithium ion, which will in future have a soil imbalance, which will reduce the soil quality of our nation. But still, we are moving to electric. Battery management system. So, a battery management system is required how we have an ECU in a car or how you have a motherboard in your CPU to tell you what is the temperature, what is your charge, at what time it's running, what is the processor speed, everything. A battery also needs a management system. And why are the batteries especially placed in the base of the vehicle? You have the front, you have the trunk, you have the roof, you have the doors. Why it is not placed? So in electric vehicles, we need a center of gravity and man maximum, mission minimum. So mission has to occupy a minimum space and when it becomes to an EV. This is the philosophy followed by Honda, a four-wheeler brand who follows man maximum, mission minimum philosophy. And EV also follows it because human has to occupy the maximum space and the machine has to occupy the minimum space, as well as you have to have a center of gravity. The batteries are placed on the floor. Also, the heat dissipation is very efficient when the battery is on the floor instead of keeping it as a pack in the boot or on the front. So when it is on the floor, due to aerodynamic, the air passes through the bottom of the vehicle, dissipates the heat efficiently. It's a natural heat dissipation system. BMS also has these many things which chooses the right cell, like I explained earlier. Mechanical design, if there is any deformation in the battery, or is it having the correct SOH, or is there is any overcharging or overheating. It also has the safety protection. If there is any overheating, it shuts down the current and does not allow the battery to charge and sends a signal to your cluster. Thermal management system. In Aether vehicles, you have seen a fan underneath your seat which cools your motor controller unit and your battery system also, which will acts as an exhaust fan to cool down, like you have a fan under your laptop. When it has to turn on, when it has to turn off. And charge and discharge control. So, like I said, when there is over discharge, it will put a control. And when the battery reaches 10% and below, when you are driving at a speed mode in your vehicle or it's a fast mode, rapid mode in your vehicles, it will automatically shift to eco mode because the battery is at 10%, now draining the battery faster due to you want to ride it at a higher speed will affect the battery health. So the vehicle will restrict you to go in any ride mode or rush mode in your low charge SOC. So how the battery management system has been. In a car, there are different grids of batteries. In different grids, there are multiple cells placed. So each cells are being monitored by individual BMS, which is connected to the main BMS system. So that when it is a four-wheeler, when there is a grid 2 cell 14 has an issue, you can easily identify which particular grid has to be replaced or affected. That is how this battery management system helps. And this is a Aether's battery pack, which will be having a casing top, a cells, and a battery management system, which is shown as point 3, and a bottom. Battery management system is a circuit which monitors all these things. So why it is needed? As I explained, we need to, when there is a service requirement or maintenance, to choose the right cell and to choose which cell is affected and get it repaired. In future, that is also a technology where you can have the battery replacements done. And this is how a battery management system looks in a car. So there are different kinds of cell. These are our blade batteries. So which is like a blades, and each is being monitored by each single battery management system, and everything is connected to a main battery management system in the top left corner. So propulsion control system. This is a drivetrain used by Tesla where a motor and an inverter is coupled together and the vehicle is driven through a differential. So here the peak power, the motor and the inverter works efficiently. It's a propulsion control system where it acts as an electric differential. So based on the propulsion control or the drivetrain, you have single motor, you have dual motor front separate and a rear separate, and you have performance dual motor where you have both, and where you have front motor as well as rear, you have a two different motors separately for both the wheels. So it acts like an electric differential. So when the right vehicle is turning right, the outer diameter wheel will rotate at a higher speed and the inner radius wheel will rotate at a lesser speed. So in between there is a differential in the axle which controls the propulsion. So this is how the motor looks, and this is the inverter which converts a DC to AC. Because when the motor is driving, it has a current which will be keep on sent to the inverter. This will fluctuate. This is a inverter which supplies the current to the battery pack. Also, at times you can see this is a Tesla. So in Tesla, if you have a high three-phase induction motor, which is an AC motor, the battery will supply obviously DC. This inverter also has a smart system which converts it into AC and sends to the motor directly. So it acts like a smart system. Current from the battery is a DC, to the motor it should be AC. Current from the motor is a when it's slowing down or braking, it's a AC current, and it converts into DC and sends back to the battery. So this is how this smart inverter works, and it also supports in moving the vehicle at a higher speed whenever required. That is why Teslas have the instant torque and instant attaining speed. And this has been explained in the previous slide also. And a four-wheel drive or any propulsion control system. So PMSM, it is permanent magnet synchronous motor, which is in synchronized with the wheels always. And there is a left and right inverter, so which converts the power from the battery to the motor whenever one motor is in rotation and another motor there is not required of power due to the electronic differential while taking a turn. That power is being transferred to the battery. So this is how it works in an electrical differential system on a rear wheel drive, which you are seeing in a Tata Harrier or upcoming electric vehicles. You have a permanent magnet synchronous motor on the wheels. So battery integration. So as we saw the center of gravity, this is how the battery is integrated with the chassis. So the chassis has a battery which is integrated, which has a heat dissipation system on the floor, which is naturally dissipating the heat, also acts a center of gravity. And thermal management, coming to the thermal management system. So in EV, we need a thermal management system to monitor the battery because continuous usage will have a battery generating high amount of heat. High amount of heat generation can also affect the circuits inside the batteries and also other electrical systems. So we need to maintain an optimal temperature. So when you integrate a battery with the chassis, there is a battery management system. For example, the battery module which you are seeing is a Nissan Leaf. So here there are 48 modules per vehicles. In one module there are 192 cells. That is, for example, in a vehicle there are 192 cells. In one module there are 4 cells. So this one module has 4 cells in it. Likewise, a vehicle has 192 cells. So 48 modules. When you place a battery like this, your heat dissipation is for the laminated batteries are higher, whereas your heat dissipation in your cylindrical batteries are less. So that is why your phones have a laminated cell batteries where the cooling is immediate. But you cannot place a laminated battery in your four-wheeler because it is placed one over the other, and you cannot have a standard cooling system where the battery at the bottom level will have the proper dissipation, not the battery at a higher on a top level. So cylindrical batteries are efficient because it is on the surface, so it gets cooled and the air can pass eventually to all the cells. So that is how the cases are being this grids. Like similarly, how we have it in a ICE engine, the engine head has been fins are there to have a compressed cooling heat dissipation. Same the battery cells are also being provided with grids. In some cases, we have a heat ventilated air conditioning system HVAC, which will dissipate the heat from the battery outside and it will move. We have a separate cooling system how our air conditioning works in a car, which pushes the cooling air into the car and brings out the heat. That is how we have a separate in Volvo and higher end vehicles. We have a separate heat ventilation system for batteries. So this is one of the cooling system where you have a turbine fan. It's like a turbocharger ideally, which will push in cool air inside, which will obviously push out the hot air out. So while whenever the sensor senses that the battery is at higher temperature, this fan gets turned on, which sucks in the cold air from the vehicle moving forward, so that the compressed air moves for inside, and the hot air from the battery dissipates out automatically. This is a very simple thermal management system. Last, closing with the charging infra and the advanced systems. Charging infra of Tesla. The concept of Tesla is like buy a vehicle and drive the country with free charge. It's like note or a selling point, but it's like a subscription. So how you buy an Apple phone and you need to have a subscription for Apple Music, Apple Play Store. Like a Tesla customer, if you have been subscribed, you can use the charging stations, and still you have to pay if you are not subscribed. So this is a selling pitch which is used in foreign countries, and they have both DC and AC charging station, also an onboard charger, which consumer has it. So these are the two type of charging typically. And what is the difference is based on the power flow and rate at which the charge is being achieved. So in general, we have type 1, type 2, CADIMO and type 2 CCS chargers globally. So type 1 charger is nothing but your AC chargers, which has a 5 pins, which you are using in two wheelers, which can support up to 11 kilowatt, 230 volts of current rating up to 32 amperes. If you go for a type 2, it has a 7 charging pin, which is installed at your home exclusively by the brand, which is a 5 times faster charging, and it is up to 400 volts also, which is a fast charging, ideally for an Indian market. CADIMO chargers, it is the chargers that you find at a charging station, which has a 4 pin, which supports up to 100 kilowatts, and it charges within half an hour to 40 minutes. And type 2 CCS combined, that is, the vehicle has 9 pins, which will instantly within 20 minutes, 15 to 20 minutes, like that, you can charge your vehicles. So, and also CCS combined is a charger type that allows a vehicle to charge both in AC as well as DC based on the requirement. The manufacturer provides a vehicle which you can charge it in both the way. It's like you have two slots in your vehicle. One is for your AC, one is for your DC. So this is the type 1 charger which is seeing on the first, which is a portable one. You carry it anywhere. That is called as a trickle charger. And type 2 charger is what 3 to 4 fast charging unit, like it is installed obviously at your home. And type 3 is your DC charger, which is at your charging station. Still more elaborated images, trickle chargers. So 1 hour if you charge, you can get up to like 15 or 10 kilometers only because it's a slow charger. And AC charger, this is 3 to 4 times faster. That 1 hour of charge, you get at least 50% or 30 to 40% of charge. And fast chargers, 40 minutes you reach 80%. And still more elaborated ones on the level 1, level 2 and the DC charging based on the charging time. So other terms we call level 1 as home chargers, and this level 1 chargers also, it's like 120 volts, like it also called as a household chargers where you plug in. Level 2, to make it easy for understanding, I have been added multiple images so that it is easy for everyone. Yes, someone raised your hand. Yeah. Yes, someone has raised your hand, I think.
Anyone want to ask questions?
No, can I come to that after completing this? Yes. Just a minute. I'll complete it. We'll go to the question sessions. And charging socket. This is the 7 pins. So EV charging sockets have an RCD, residual currents. So PRCD we say. So the PRCD, what it does is it potential residual currents, it deflects it. Like when you plug into a socket, there are earthing. The high current goes to the earthing. It will not come directly to your product or your instrument. It will protect the system. The PRCD and the RCD it is built in RCDs. So every EV charging socket has an RCD, residual current, so deflectors, so that it will protect the car or vehicle battery and the vehicle from short circuits. And these are the types of AC and type of DC chargers. So AC type 1, AC Type 2 has 7 pins, AC Type 1 has a 5 pin, and DC chargers have a CADIMO, and DC charger also has a CCS combo where you can charge your car with AC or with your DC current. So the manufacturer itself provide a car with a two particular slots. So this was taken from the global markets. Like Japan has a standard system of charging plugs and DC charging plugs. So any manufacturer who sells a vehicle in Japan, China, and America has to follow this pin. That is why they have a charging infra where it has been standardized. All the vehicle with the AC current in Japan has this type of charging pins only, so they can go to any charging station and charge it, or a DC charging station and charge it. All has a type. So CADIMO, it's like charging on the move. So it's like a charge while you move. It is a Japanese word. From that they derived this name CADIMO. It is like having a cup of coffee while you charge. So that is where the name has been derived. So this is how the CADIMO looks like. You can see a car with both AC and a DC. So anything as per the availability, the consumer can charge it. So requirement for a charging station is a transformer and 11 kilowatt cable supported equipment, space, and a government authorized license. So we are we are still in progress in Indian nationwide for an EV infra. So presently we have the range anxiety and we don't have an established or a proper charging infrastructure. And for a solar, it's very cheaper, but maintenance has a higher rate. So you can see many charging stations where a solar grid has been fixed, and on daytime it charges, and whenever it's available, the cars can charge from the solar. And also maintenance is high, as well as power storage is also less because it can support only to one car for one shade of solar charging station. Advanced system, moving on to EVs, augmented reality, AI system. So AR and AI integrated system where there is no driverless and it's a automated system which is semi-autonomous and autonomous driving. That has been a new trend. Common features in EV: navigation assist, auto parking. Now the vehicle parks by itself on the 360 parking and with the sensors. And theft log, service records, everything you get it on your mobile apps. What are the features do car buyers want? So if a car buyer, he needs a technology, now latest one. So they will go for a new car. Standard tech features are nothing but smart app connectivity, rear cameras, and heat assist. But a techie car buyer, he will look for a user-friendly system, integrated systems which can seamlessly integrate with the smartphones, and heads-up display, and fingerprint profiles that is also required, and a parking assist. So voice operated system. And also nowadays you can see cars to reduce the aerodynamic, they removed the side mirrors. Instead, you can see a cameras there. So that cameras are being displayed inside on the left or right panel like a display screen. So the rider can see the real screen because they no need any side mirrors exactly fixed there. And other technologies are connected vehicle technologies. Now your car has a connected vehicle, and there is one more connected vehicle technology car. Both can communicate. So when there you can see the truck drivers in abroad countries, they have a walkie-talkie to communicate with each other to overtake. Or if the trailer has been not tucked properly, or there is any loop straps. So likewise, each car can communicate with them, and if you are overtaking a car, that will sense by internally signal will be sent to the other car to alert them that there is a car overtaking behind you. It is the speed of the behind vehicle is increasing, and now you are seeing in ultraviolet, the bike itself has a rear sensor. So when you have anyone overtaking you from the blind spot, you can see your side mirror alarming you or with an indication, so that there is a overtaking vehicle at your blind spot. adaptive cruising, heads-up display, adaptive LEDs, and the car has been monitored 360 way, where human intervention has been reduced 50%. Now the human can focus on driving as well as he can leisurely drive because the car itself takes care. And connected vehicle technology, there are a few things like when a vehicle comes forward, semi-autonomous braking system, auto braking system. When the vehicle detects that there is a car and the rider is intentionally moving forward, the car will alarm the rider, acoustic warning and optical warning. Optical warning will come as first. This will alert you to identify on the cluster. Okay, someone mute.
Tilak sir?
Yelamale, I think, can you mute for 2 minutes?
Yes, sir. I'm checking.
Yeah, please.
Sir,
So when the car intention, yes.
actually up to 9 o'clock only, but all are asking to.
Oh, sorry. I thought it's 9:30. My bad.
No,
Sorry then. Fine.
no, 9 o'clock. Sir.
Yeah. Fine. I'm fine with that. So this is the last slide. That's all finished.
Okay, sir.
Yes. So this acoustic and optical warning stops your car in even though if you accelerate it forward. So I can share this details on the group. I think all the participants are there. I will share these details so you can see through this. Okay. So thank you so much. This is the end of the session. So I think it was a information has been delivered well. If there is any doubts or something, people can ask. Or
Participant,
already it's a time.
anyone want to ask question, you can ask.
Hello, am I audible, sir?
Yeah, sure. Yes. Yeah.
Sir, you have said there are 48 cells in a one.
48
And
48 modules
yes,
and
48
192
modules
cells.
and each contains the 4 cells. Okay.
Yes.
So, what is the cost of that total set? Approximate cost?
Cost wise, that is what in EV technology, the cost of one battery, we are not at that particular level to replace or repair on the battery cells now. So, in the industry specific, if you are saying cost of a battery of an Ola scooter is around 70,000. The scooter itself cost 1 lakh. If you go for a Nissan Leaf, the car approximately, if it cost you around 15 lakh, the battery cost will surely come up to 8 or 9 lakh. So now presently there is no manufacturer allowing to battery repairing system at the service centers or at locally. So the cost is not still specified.
Oh, thank you, sir.
So in the particular industry, you don't have people like if you are a customer, you cannot depend on a people to work on your battery, how safe it is compared to the manufacturer standard. So the manufacturer doesn't allow or authorize anyone to locally work on the battery. They recommend only to replace the battery as per a manufacturer standard fitment. So it's always better to replace the complete battery rather than reworking because still we don't have that particular knowledge level at the field like we have now mechanic shop for ICE engine. Still we will be there after years. It will take some period where people are aware about battery technologies.
Hello.
Yeah.
Yeah, sir. In context of population density in India, in context regarding with cost and
Hmm.
range of the
Hmm.
EV, what
Yes.
you are seeing in the future trends that people will adapt or manufacturer will see the future as a hybrid vehicle in India or purely electrical vehicle because our government right now focusing on zero emissions. So like Nexon and other vehicles are pure EV. Our vehicles
Hmm.
are
Hmm.
more in the
Hmm.
on the
Hmm.
road.
Hmm.
But somehow has been here that hydrogen based vehicle is going to be a future or replace the technology. So in
Okay.
context with the range and cost, what you are seeing that which vehicle will take over?
So a good question actually. Now, if you see Delhi market, if you see central government has increased the what to say? You get benefits on EV when you purchase it. Okay, subsidies have been increased. As well as if you take in the future, EV will be recommended for a passenger vehicle, like below the passenger vehicle, as well as commercial vehicles, because this will surely shoot up the pollution where Delhi is facing it now. And Delhi completely EV now. Every vehicle, if you see in Delhi, are most 20-30% are EVs, and autos have been completely EVs now in Delhi. So soon there will be a government role, because governments are keep increasing the subsidy, encouraging people to buy EV. And if you buy a EV vehicle, there are some benefits on the taxations. So surely you can see 50% conversion of EV in national wise in next 5 years. So soon
But
many
sir,
people. Yeah.
government is encouraging, but if I don't know whether it is not feasible or technology is not there to swap the battery, because battery is at the floor of the vehicle, and it is easy if they encourage to battery swapping business, then it will be easy for purchaser also buy the vehicle at the
Correct.
half of the price of EV. Then uh, I think it more and more EV will be sell out. So range
See,
anxiety will be, I think,
I have two
eliminated.
questions. I have two answers for your question. It can be a defender also, but it is a practicality. Now you are using a mobile phone. When mobile phones were introduced, your batteries were swappable. You would replace your battery of Nokia. Now, how many people replace their battery on a periodical way? No one. And batteries are fixed. And if you go for an EV, now you get a EV below or a cheaper than buying a mobile phones. You buy a mobile phone of 1.5 lakh, but you get a EV at 60,000 also. Likewise, now the technology is at a very higher stage when people awareness are very higher stage where batteries are not standardized. And even the charger, if you buy a phone now, you have C type, and your even the C type is now standardized. Every mobiles are having C type except iPhone of older models. But still, this standardization which global market, as I showed, Japan, America and Tokyo has implemented, will be implement once it is implemented in Indian markets. Then you can see the sustainability, deliver a product which can fast charge. And surely fast charging, as your thing, it's very right. Fast charging will deploy your battery, but that is a consumer demand. I am ready to pay what I want. I need the requirement on demand. So the vehicle is adaptable for fast charging as well as slow charging. It is based on your usage. If you want, your vehicle can drive up to 200 kilometer also. It's not everyone are not driving at 200 kilometer. Based on their requirement, they drive. It depends based on the consumer requirement. As a manufacturer, it's our responsibility to deliver a product which satisfies the consumer need.
Okay. Sir, okay,
Yeah,
sir. Sir, last question, sir.
yeah,
Hydrogen-based
yeah, sure.
vehicle is going to come in a future that in practical way. Because hydrogen is
Practical way,
very difficult to
hydrogen
store.
fuel cell technology, it's developing by Toyota, so and Hyundai also. But still, it's at a concept range. But still, few places in Japan and China, they have started using it. It's not at a higher rate. People like CNG, how we have an issue like, and we have some afraid about it. Same goes on hybrid. This hydrogen fuel cell will take a time span. It's not an immediate, but still there are alternative searches going on. Surely, but not
Okay, okay,
immediately. It will be.
Any other participant question want to ask?
okay.
Sir Tilak sir, I think that's all.
Okay.
Sir,
Okay,
thank you so
Ilmani.
much for accepting our invitations to deliver these lectures, and it will be
With
very
pleasure.
useful to that all the participants, sir.
Okay.
Sir, tomorrow morning I will share the feedback of participants, sir.
Sure, Ilmani.
Okay, okay, sir. Thank you, sir. Thank you so much.
Thank you so much, everyone.
Thank you, sir. It was a very nice session. Thank you so much, sir.
Yeah, it's my pleasure. Thanks.